Welcome to beginner level course on data analysis and visualization. Meet our team who played a role in researching, designing and creating this course. Together we have close to 25 years of experience in practical implementation of technology and teaching technical courses at a university level. We will have a total of 8 sections that are designed to help the students learn R programming progressively. We will start from the basic introduction of the course and gradually move to the intermediate concepts. We will cover the concepts of data types in R, followed by the control structures in R, then we will deep dive into the R functions and then the data structures. After having enough knowledge of programming in R, we will move to data visualization in RStudio. Key concepts throughout the course are explained visually to enable our students grasp the technical concepts quickly and effectively. The lab portion covers the key concepts of the R programming language, starting with setting up your environment for R and RStudio, then moving on to the understanding of data types in R. We also have detailed practicals on the basis of R for taking user inputs, printing the outputs, looking at the conditional statements, making functions, and evaluating the built-in functions. We will also deep dive into the data structures in R. And finally, the visualization in RStudio. Hi, and welcome to the section 1 of this course. In this lecture, we will see how to download R. So let's open your browser and search for R download. Now click on the first link here and proceed to download link here for downloading R for Windows. There is no need for any prereq for downloading R, and for the installation details related to the operating system, you can read our official documentation. So we are done downloading the installer. Now launch the installer, and here it is. Our R installer is launched. Now follow the default instruction of the installer to download R successfully. So the installation is in process and it will take some time to finish the installation. So the installation is done. Now click on Finish button and launch the R console from Start menu. Here is the main window for the R console. And if you want to enlarge the text size, you can go in Edit option and increase the font size. Let's set the size to 16. And here you can see the result on the screen. So in the next lab session, we will see how to download RStudio in your Windows operating system. Hi, and welcome to this lab session. Here we will be looking at an overview on R console. So when you install the R on your PC, this is what the console for the R looks like, and is the same when installed on any of the operating systems. The greater than symbol over here is the R terminal, where we can write the R language command that needs to be executed. R console is a glorified calculator that executes whatever you write and press enter. Let's quickly run some mathematical and logical statement. So I have typed here 45 plus 90, and as soon as I press enter, it gives me the result, that is 135. Next I type in 48 into 3, which gives me the result 144. Next I perform the subtraction of 89 minus 789, and it gives the result minus 700 as expected. Now let's have a look at some of the logical statements, and here we are comparing that 500 is less than 200. We know the statement is false, and on pressing enter we get false. You can also use the logical statement directly within the print statement, like here I want to print the result for 45 less than 50. The answer on execution is true as the statement is valid In the R code editor console, you can browse through the previously executed commands using the upward and downward arrow on your keyboard. And to clear the screen, you can press the Ctrl and the L key simultaneously. Now to save the code, you can save it to a file from the option here. Once you click on the Save to File, a window pops up asking you for the location where to save it. Alright, moving on forward, there is also an option to save the workspace. This helps to avoid any code retyping or reconfiguration. So in order to do so, just give the name of your workspace, and here I'm giving it my first code. Avoid spaces in the name and save it. So it shows the saved image for the file workspace. So you saw how it's easy to write and run the code in R, but R is a GUI with very limited functionality. Doing some jobs is difficult in R console. So for that, we need some advanced and easy to use IDE for R programming. Various paid and free IDEs available on the internet to be used with R, but RStudio is the best choice. So in our next lab session, we will look at how to download and install the RStudio. In this lab session, we will look at how to download and install the RStudio IDE. To download RStudio, let's just type RStudio download in the search box and click on the first official RStudio download link. You can see the 4 different RStudio versions. 2 versions are paid and 2 versions are free. Here we are interested in RStudio Desktop. So click the download button under RStudio Desktop version here. You have RStudio available for different OS platforms as well. I'm using Windows, so I click the blue button to download the RStudio for Windows. Now download it. The download size is more than 160 MB, so it may take some time. And here it is, download completes. Now launch the RStudio installer. Now always remember to install the R language console first before installing the RStudio. If you install RStudio before installing the R language, your R language console won't be detected by the RStudio. Here the installer has started. Follow the general on-screen instructions and actions to complete installation of RStudio. Now the RStudio installation is completed. Click the Finish button and launch the RStudio from Start menu. RStudio may take some time at first run, and it is loading up right now. And here is the RStudio graphical user interface with a bunch of different sub-windows. The large window with greater symbol is the console window. And at the right of GUI, we have environment, history, and connection windows. At the bottom of environment window, you can see the plot, package, files windows. We will discuss shortly the purpose of important sub-windows of the RStudio. Let's first increase the font size of console window. To do so, follow the on-screen options and actions to increase the font size of console windows. And under Appearance, you can change themes, font size, and other related settings of console window. Let's set the 14-point font size to make code look bigger. So in our upcoming sections, we will explore the RStudio and run the code. Hi and welcome to this lab session. In this lab, we will look at how to download and install R and RStudio on a Ubuntu operating system. First step is to install R. Now to begin first, we need to update the packages index list. Open up terminal and enter sudo apt get update. It will ask you for the password. Enter your password and continue. Next, we will download R using the command sudo apt get install R base core. Hit enter, type in yes. The R starts to download. And here you go, R is installed on your PC. Let's see if R is installed correctly. So for that, type R in uppercase and hit enter key. Here you go. Let's run some commands. So it's running perfectly fine. The next step is to download and install the RStudio. To download RStudio, go to web browser and type in RStudio. Go to the official download link. Here we are interested in RStudio desktop. So click the download button under RStudio desktop version. Okay, so now under the download page, you are able to find the Ubuntu version. So select accordingly and click on download. The download is complete now. Let's open the terminal once again and type this command. Now hit enter, type in your root password, say yes and continue. So now the RStudio installation has been completed. Let's launch RStudio. And there we will run few commands. All good, we are done. Now in our next lab session, we will look at how to set the present working directory in RStudio. Hi and welcome to this lab session. In this lab, we will look at how to set up your working directory in RStudio. Here is the console. We have already seen this. I have just changed the layout and background color and font. Here at the bottom right corner, you can see the files that are present in the working directory. Setting up the present working directory is important because whenever you want to import some external files, for that case, you must ensure that the file being imported is present in the present working directory. If this is not the case, then you will need to give the complete link of the file you want to use in the RStudio. Now to check your present working directory, go to the console and type in getwd, that is working directory. On executing it, you can see your present working directory. Now let's see how you can change the working directory to your custom folder. Suppose I want to locate this folder location, and in this folder I have this dataset file which I want to import. I will copy the folder link to make it my present working directory. Then I will move on to this session, go to the set working directory, and click on Choose Directory. Locate your folder and open it. So now here you can see that the working directory is now set to the one we need. And if I check the working directory, it is same as we needed. So the dataset file can be seen in the Files window. So this is how you set your current working directory in RStudio. In our next lab session, we will look at the workspace in RStudio. Hello and welcome to this lab session, where we will be looking at what is workspace, or you can say the environment in RStudio, and how you can save it. Whenever you run or execute lines of code in RStudio, you use variables in the code. Like for example, I'm writing here x equals 7. So you see in the environment window that the x variable is assigned a value 7. Similarly, if I type down sum1 equals x plus 25, so this variable on execution contains the answer 32, which is actually the sum of 7 and 25. Similarly, let me create a variable name underscore 1 and store a value Williams in double quotes as it is a string value. You can see that here we have the same variable with value Williams assigned to it. Currently, you see that the variables we have used in the console code execution is also available to us in the workspace global environment. What if I clear them? So if these are to be used further and we clean them all, we will need to declare them again and again. So in order to reduce the overwork of declaring these variables again and again, you can save the workspace. Just click on this save icon over here. Give it a name as my workspace 1. So you can see that the workspace file is saved in our present working directory. Now let me clear it and show you the importance of it. So the variables are now cleared, and now if I go to the console to access those variables again, like someone for our case, it gives an error because the workspace does not contain that data. Again, if I access the variable x, it again gives the same error. So how can I access it? If I go to the load workspace option and load my same workspace 1 which I just saved, so now when I want to access the variables declared previously, you see it shows you the values because the workspace is loaded in our global environment. In this way, you have the access to the variables again. Similarly, if I access some1 variable, it will give you the answer, and same is the case for the name1 variable. So this is how you can save the workspace for future use. And in our next lab section, we will look at variables and data types in R. Hi, and welcome to this section on data types in R programming language. Before moving on to the data types, it is important for us to have an overview on variables in R. The variable is a memory location where we store some type of value, and where they can be altered or updated where and when desired. Variable name is also known as an identifier as it helps identify the values that are stored in the memory. Just take a note here that R is a case-sensitive language, which means that two variables can have the same names but different case types. Like if we see here two variables ABC and capital ABC with both having the same name, but for the first one, A is small case and second one has a capital A. Here, let's have a look at the example. We have two variables, n1 and n2, having values 345 and 56.3 respectively. So once these values are declared, they get stored in memory locations, also known as containers. Now, these can be accessed with the help of identifiers, also known as the variable name. Next, we calculate the sum, in which we calculate the sum for n1 and n2. So we get the answer as 401.3, which is stored in variable sum at a memory location. So here we have some naming conventions for variables in R. Any variable name in R must start with a letter, and it can contain a number, letter, an underscore, and a period, which is a dot symbol. Here we have variable name 1 and 1 dot variable, which are valid variable names in R. A variable name cannot have an underscore at the beginning of the variable name. And here we have an example with variable name as underscore variable underscore 1, which is invalid. In R, a variable can start with a dot, which is also known as period. But this variable name should not be followed by a number. As can be seen here, we have .1 my variable, which is an invalid variable name in R. Reserved words or keywords are not allowed to be defined as a variable name in R. Special characters such as hash and etc., along with white space like tabs, space, are not allowed in a variable name. Let's quickly have a look at the naming conventions for the variables in R programming. A valid variable name consists of letters, numbers, and the dot or underline characters. The variable name starts with a letter or the dot not followed by a number. For the first case, we have a variable name that contains a special character, which is not allowed in naming a variable in R. So a variable name can only have a dot or an underscore. Then next we have .var underscore name1 and var underscore name1, which are both a valid variable name in R. .1 var underscore name is not a valid name, as we have already seen that a starting dot must not be followed by a number. Then we have some other examples as well listed here. We will discuss them in the lab part as well, trying to declare all of them and see what invalid errors we get while declaring them. Till now we have seen how to name a variable. Next, we will see how you can assign a value to a variable in R. Now there are three ways to declare a variable in R. You can either use a left word operator, a right word operator, or an equal to operator to assign a value. All of these methods will work fine. Here I have tabulated all the three methods to assign a value to the variable. However, the values variable can be assigned in three different ways, but the primary one is the left word operator. And it is recommended that you always use this operator to assign values to the variable all the time when using our programming language. Once the variable is created and if it is no longer required, it can be deleted or removed from the workspace. So to remove or delete a variable, we use the command rm. Here we first declare a variable var with value 15 assigned to it. If you just type the variable name and press enter, it shows the value for that variable. To delete the variable, we use the command rm and in the bracket write down the variable name that you want to remove. This will delete the variable and remove it from your workspace. Instead of using the conventional method of declaring the variable as in C or C++, where you define the variable type itself, either it be an integer or float, etc. In R, you directly assign the values to the variables. In this way, you might be interested in knowing the type of the variable as well. So here are the two functions used to know the variable type for the assigned value. When we use the mode function, the type of variable in R is determined. Mode is a mutually exclusive classification of objects according to their basic structure and is the basic building block for data objects in R. There are 6 basic atomic modes: logical, numeric, complex, character, functions, and mean. Then we have the type of function. This returns the low-level value which matches the internal type of object in R. We will have a look at these in our next lab session lecture, where we will be practicing all the theoretical concepts discussed in this lecture. So, see you in the next lesson. Hi, and welcome to this lab section, where we will be looking at the data types used in R programming language. Starting with the basic definition of data types, a data type specifies the size and the type of information that the variable will store. Talking about the R language, it has 5 main data types: the character data type, complex, the numeric, which can be either real number or decimal numbers, also known as float, the integer data type, and the logical data type. Let's see each one of them in detail. First in the list we have is the character data type. It stores the character values or strings that can contain alphabet letters, numbers, and symbols. This data type value is written within a single inverted comma or a double inverted comma. And here are a few examples of the character data type values. The letter A, value 2.112 in a double quotation marks, skill at the rate, and atom. The R programming language supports the set of all complex numbers. This data type is used by R to store numbers that contain imaginary components. The examples are 1 plus 3i, 5i, 5 minus 9i. Any number with or without decimal point, that is, any decimal value, constitutes numeric data type. The numeric data type is for numeric values, and it is the default data type for numbers in R. Examples of numeric values would be 1, 20.5, minus 97.054, minus 65. The integer data type is used for integer values. This data type stores non-zero values. To store a value as an integer, we need to specify it as such. We can store as well as convert a value into an integer type using the as.integer function. The logical data type stores logical or Boolean values of true or false. The values are often generated as a result of logical operations. Now let's move on to the practical exercise for each of the data types we have discussed. In this lesson, we will learn about some important concepts of strings in R, and then we will move to its practical concepts in RStudio. String is a character that is made of one character or contains a collection of characters. It is enclosed inside single quotes or inside the double quotes. But in the internal representation of R, strings are represented in double quotes. Talking about the rules for strings in R, the string that starts with a single quote needs to end with a single quote. However, you can put double quotes, and through the escape sequence, single quote can also become a part of the string. For example, buses, written in a single quote, marries, written in a single quote, marry, escape sequence, S, written in a single quote, are valid strings in R. The string that starts with double quote needs to end with a double quote. However, you can put single quotes, and through the escape sequence, double quote can also become a part of the string. For example, buses written in the double quotes, marries written in double quotes, marry, escape sequence written in double quote are also valid strings in R. Let's move to the RStudio and have a look at how we can declare strings. Hi, and welcome to this lab session on variables in R, where we will be looking at the aspects for variable declaration we discussed in our theory session. Here is our script for this lab, and you can also find it in the resource section as well. Here is our script for this lab, and you can also find it in the resource section as well as in our Git repository. So variables, as we know, are used to store data. So to assign a variable in R, we use the leftward arrow operator. For our first example, let's assign value 1 to the variable x. Now to run the specific line of code where our cursor is, just press Ctrl plus Enter key. And that line will be executed just like this. So now you can see that the line is executed with output shown in the console below, and in the global environment window that a variable x has been declared with a value 1 assigned to it. Next, we discussed that R is a case-sensitive language, which means that even if the variable name is the same but have different case letters, they both will be different for R. Let's see this. So here I have declared a variable with all lowercase letters named as ABC and assigned value 15 to it. Once I run this line, you can see a variable ABC is declared with value 15 assigned to it. Again, we have the same variable name ABC, but here A is uppercase. Now let's run it. And you can see that now we have value 32 assigned to it. That proved that both these variables are different for R. Let's move on to our next example. And here we will assign value 345 to variable N1. Now run this line. Next, we will assign value 56.3 to N2 variable. I am interested in calculating the sum for the variable N1 and N2. So for which I have written sum equals N1 plus N2. On executing this line of code, I will get the answer. And the answer is 401.3. Let's have a look at the naming conventions for variable in R. We have already discussed that a variable name must start with the letter and can contain number, letter, underscore, and period. So I have declared the two variables, variable name 1, which contains the number and letter in the name. Let's execute and assign the value 23 to it. The code executes and you can see in the global environment as well that we have this variable declared. In the same way, we have another variable with the name 1.variable. And let's run it so that value 27 is assigned to it. Alright, so here you can see that this is also a valid variable and the value 27 is assigned to it. The next rule says that the underscore cannot be used at the beginning of the variable name. So for that purpose, I have declared a variable with name underscore variable underscore 1 it already shows a red cross left to the line number 40. As you see here, just hover over it and it already says unexpected token underscore, which prior to execution warns us that the variable name is not valid. But let's try to assign the value and see what error it gives. So it says unexpected input in underscore, which means that we cannot declare a variable in this way. Always remember not to use an underscore in the beginning of the variable name. Okay, so let's move ahead to the next rule. Likewise, underscore, you cannot use a dot followed by a number at the beginning of a variable name. If I try to assign value 33 to the variable name dot one my variable, you see it gives an error saying an unexpected symbol in dot one my variable. However, you can use a dot directly followed by a variable containing letters only. So now if I try to assign the value 30 to the variable dot my variable, you see that the line executes without any error, and in the global variable, the value cannot be seen because in R, the dot variable name declares a hidden variable. A hidden variable mostly used by developers for the development purpose. On writing the variable name directly, like in the line 48, I want to see the value of the variable. So I have written dot my variable, and when you execute it, you can see it contains the value 30. To remove a variable, we simply use the rm function. Here we will remove the variable n1 from our environment. So on executing the line 61, you see that the variable n1 is removed. I hope you have got a clear understanding of how variables are declared and what are the naming conventions to take care of while declaring the variables in RStudio. This is it for the variables practical. See you in the next lab session. In this lab session, we will look at what are logical data types and how we can perform some comparisons to get a logical output value. A logical data type can have either of two values. It can be true or false. It is basically a Boolean value. Here I have declared a variable x with the value true. Notice the color of the word true. This is because it is a reserved word in our programming language. And when I execute this line, you can see that the value true is assigned to the variable x. Likewise, I will do the same for variable y, but this time we will assign the value false to it. You can also use the keyword t and f for true and false respectively, as I have done here for the case of variable x1 and y1. Now let me execute it for you. Notice that the variables are declared in the environment section with their values as true and false. Let's make use of the two functions we studied earlier to know about the variable type and its mode. So here in line 14, I have typed in the type of x1, and on execution, you can see it shows that the variable type is logical. Also, the mode for the variable is logical as well. We will now perform some value comparison in R, so the comparisons always return a true or a false value. Let's have a look at it. Here I will perform the comparisons for less than and greater than. Let's begin with 98 greater than 32. And we know it is a true statement, and on execution, it must return value true. So you see when I execute it, I get the value true. Next we have 37 greater than 52. and it is known that the statement is false. So on executing, we see that it returns false as expected. Likewise, I have the statement 87 less than or equal to 92. So we know that it follows the condition and 87 is less than 92. And here on execution, you see it gives true. Similarly, we have 1 is greater than 9. And on execution, as expected, it returns false because 1 is not greater than 9. Next, we will perform equivalence comparison. First, we have 57 equals to 34, which we know is not true. So when I execute it, I get the answer false. Then we have 80 equals 80, which is true. When executing this line, it gives us true as well. You can also compare strings together. And here we are comparing high with high, and both are equal. So when I execute it, you see it returns true. So this is it for the logical data types value. Hope you have got an understanding of this data type, and also while performing the comparisons, the answer we get is of the same data type, which is logical in nature. Now in our next lab session, we will look at the integer data type. In this lab session, we will be having some practical overview of integer data types in R. R supports integer data types, which are the set of all integers. You can create as well as convert a value into an integer type using the as.integer function. You can also use the capital L notation as a suffix to denote that a particular value is of the integer data type. Here you can see that we have assigned a value 9L to the variable x, which specifically means that we are assigning an integer value to this variable. This can be clarified when I run the class x function. So you see we get the class as integer. In the same way, now I have assigned 9 to the variable y. So now when I see its class, it shows me numeric. This is because I haven't specified the specific type of it to be an integer using the letter L. So we have the variable x1 and I will assign it value 19.0L. Now execute it. You get an error that integer literal 19.0L contains unnecessary decimal point. This is because integer values do not contain any decimal point or floating point numbers. So whenever you assign an integer value, ensure that it is not that case. Now I will assign 19L to variable x. Now when you execute it, it gets assigned, and let me see the class of this variable. So it is an integer just as we needed. You can also convert any numeric value to an integer data type using the function as.integer. This is known as coerce function. So here is an example of it. Here we will assign the y1 variable value, which is 33, using the function as.integer. Now let's execute it. So value 33L is assigned to y1, and if I check the class, I get the integer class. This time we have a decimal point value 31.2. So we will assign it to variable y2. When it is executed, you can see that the value 31 is assigned to y2. This is because when you try to convert the floating point value to an integer value, it only takes the whole number part out of it and saves it to the assigned variable without rounding it off. Let's now try to convert a string value to an integer. So I will convert this string value 8.65 to integer and save it to variable y3. Let's execute it. So you see in the global environment value, 8L is assigned to y3. If I check the class, so here you go, it is an integer. In the same way, you can also convert the logical values which we have seen previously to integer, as we already know that a true value is represented by 1 and a false value by 0. Same case will be found over here. So in line 32 of this code, we are using as.integer function to convert true logic value into integer, and store it in logic underscore true variable. Let's execute it. So 1L is assigned to it, and if I only type the variable name and execute it, so it will return for me the value of it. This is how you can also print the variable and check what's inside it. So I get the value 1. Same is the case for logic underscore false variable. I will execute both statements on line 35 and 36. So it gives me the answer 0. Alright, so next we will be looking at how you can actually check if the variable is an integer or not. So for that we use the function is.integer. This basically returns a logical value. If the value is an integer, it will return true, else it will return with a false value. The first statement we have at line 39, it checks for the value x if this is an integer or not. So for reference, we can see these values in the right side window for the global environment variables we have. When executing the first statement, we get true because the variable x have the 9L value, which is an integer. Next, let's check the variable y if it is an integer. So we get the answer false because 9 itself is a numeric and not integer. This is how RStudio interprets the variable. Let me quickly do the other for you. So we have true value for the y1. We get a true value because its value, as can be seen, is 33L. Alright, so moving on forward, we will now create a vector m with values from 1 to 5. Let's execute it. So you can see in the global environment window, values 1 to 5 with integer, which is short for integer data type, are stored in variable m. If I print the variable values in the next line, so you get the values from 1 to 5, and the class for m is integer, as can be seen here. So here is the bonus part for you. While you might be wondering what is the difference between the integer and the numeric. So the main answer to this question is the number of values they can store. If you see on line number 53, I am actually looking for the maximum value that can be stored in integer data type variables. Let's execute it. So the answer is 214748367. That is around 2 billion. But if we check the same for the numeric data type, it is way more than 2 billion. With this, I hope you have got an understanding of what are integers data type and how they work in R. In our next lab session, we will look at complex data types in RStudio. In this lab session, we will be working with complex data types in R on RStudio. R supports complex data types, which are set of all the complex numbers. The complex number type is to store numbers with an imaginary component. Let's assign a complex value 8 plus 5i to the variable x. So it has a real component as 8 and imaginary component as 5. Let's execute it. And when I print this variable x, I get the value 8 plus 5i. And the class turns out to be complex as expected. Next, I will assign the complex value only with the imaginary component this time. So variable z is assigned with 5i. If we see the variable z, we get the value 0 plus 5i. So we have real component as 0 and imaginary component as 5. And the class can be seen as complex. You can also convert any value to a complex data type using the function as.complex. As our first example in line 15, we have value 3, which is the real component with imaginary component as 0. So it must return the value 3 plus 0i. Let's execute it. So you see we get the same result as we expected. Next we have as.complex 6i. The answer should be 0 plus 6i, which is self-explanatory as in the previous case. So here we get the same result as we expected. Now let's apply square root function on complex number. So first in we have square root of -1. So the square root of -1 is I. Now let's execute it. So here you see it gives a warning message. Reason being that we haven't specified the complex number and the function takes the value as numeric. So the correct way of calculating the square root of -1 as a complex number is written here in line number 23. So here we have specified in the square root function that we are finding the complex number -1 square root. And on executing it, you get the answer I. Another way of writing this is the way written here in line number 26. Here inside the square root, I have written as dot complex -1, which means that the square root function should treat the value -1 as a complex number when calculating the square root. So let's execute it. And you see we get the same answer I. You can also perform all the arithmetic operations on complex number as well. For example, I have two values here, y1 and y2. And when we perform the sum function in the line 32 and execute it, so it calculates the sum. And let me display the variable value for you, which is 8 plus 11i. Now check the class of the variable sum underscore y, and it is complex. So I hope you have got a clear understanding on complex data types in R. In our next lab session, we will be looking at the character data types in R. In this lab exercise, we will look at the character data types in R. As previously discussed during our lecture session on data types in R, that a character can be written within a single quote or a double quote. First, here in line 6, I have declared a variable character and assigned character value a to it within the double quotes. Let's run it. So the value a is stored in a variable, as can be seen in the global environment window as well. If I print this variable for you, so here we see the character a as output. If I check the class of variable character, so here it returns the character. Again, I will declare a variable character 1 and this time assign a character value to it using the single quote. So the variable now contains the character b and the class is character. You can also convert any value to the character data type using the function as character. So here in line 16, I have a variable pi underscore value to which I have assigned the value as 3.14. And now in line 17, we assign this value as character to value x. So now the variable x has value 3.14 and its type is character. Now let's have a quick look on how we can concatenate the characters. Here we assign first name as value William and last name as value John. So now to concatenate the character, we use the function paste. So in line 29, we use the paste function and here we write paste, then the first variable and the second variable that needs to be joined together. So we are joining the first name and last name here and storing it in variable full underscore name. Now let's run it. And if I print the variable full underscore name for you, so here we get William John. With this, I hope you got an idea of how to work on characters in R. We will have more discussion on it when we will talk about strings in R. And in our next lab session, we will talk about numeric data type in R. Hi, and welcome to this session. In this lab session, we will look at numeric data types in R. So, starting with assigning a decimal point value 12.7 to the variable x. Now see the value inside x. And the class of x is numeric. And the type of x is double, as it is a decimal point value. Next, we assign value 14 to x1, which appears to be an integer. But we know that by default in R, all values are assigned as double. So let's see the value inside x1. And the class of x1 is numeric and type of x1 is double. So you can convert an integer value to a numeric value, and here we assign 15L to x2. So now the class of x2 is integer and its type is also integer. So next I will convert this value of x2 to numeric using as.numeric method function and store it in variable x3. Let's print it. We get the value 15. The class of x3 is numeric and its type is now converted to double. This is how we deal with numeric data types in R, and in our next lab session we will look at strings in R. See you in the next lab. Hi and welcome to this lab session. In this lab session we will look at how to declare strings in R language. Any value that is written within a single quote or double quote is treated as a string in R. So before starting with the coding part, here are few rules for string construction. Let me quickly go through it. First is that we can only use single quotes or double quotes can be used at the start and end of a string. Second is that double quotes can be inserted into a string starting and ending with a single quote. Third, single quote can be inserted into a string starting and ending with double quotes. Fourth, double quotes cannot be inserted into a string starting and ending with double quotes. Fifth, single quote cannot be inserted into a string starting and ending with single quote. Let's see all of these while coding in RStudio. So we have the first variable x1 in which we declare a string with single quotes. The line executes and when I print the variable x1, the string value is returned. So now we have the variable x2 in which we declare a string with double quotes this time. So the line executes and now when I print the variable x2, the string value is returned. So we have the variable x3 in which we declare a string with double quotes with a single quote in between the string this time. Now the line executes and when I print the variable x3, the string value is returned with a single quote in the string. So now we have the variable x4 in which we declare a string with single quotes and with a double quote in between this time. The line executes and now when I print the variable x4, the string value is returned. But this time in place of a double quote, we also see a backslash printed. So we have the variable x5 in which we declare a string with double quotes and with a double quote in between. But you see the code shows an error on line 32. And if you try to execute this, it gives an error. So this is because we cannot use double quotes in between strings declared with double quotes as discussed earlier. So I hope you have got an idea of how to properly declare the strings in R. In our next lab sessions, we will look at string concatenation. Hi and welcome to this lab session, where we will look at how to perform string concatenation in R. So concatenation is the process of appending one string to the end of the another string. Here I have declared three different variables, x1, x2 and x3 with different names in them as Olivia, John and William respectively. In order to check the number of characters in a string, we use the function nchar. This gives you the character count for the string you give as an input to it. So for our example, we are interested to look at character count for x1, x2 and x3. So let me run the nchar at line 10 for you. So it gives us the value 6 and we can also see that the word Olivia contains 6 different characters, or you can say letters as well. Similarly, let's run line 11 and 12. So they return us 4 and 7 respectively, which is self-explanatory. Let me tell you that RStudio by default contains many vectors pre-stored with different categories. So for this case, I have a variable letters which stores the letters from A to Z. So if I run the code at line 16, you see it returns the letters from A to Z. Let's say I want to access the fourth value from the letter. So for that, I will write letters and within the square brackets, type 4. So you see it returns the letter D. Similarly, if you want to access a range of value from a letter, like I'm extracting here letters from 1 to 5. And here it returns me letters from A to E. Now let's have a look at string concatenation. To concatenate string, we use the paste function. Here is the syntax for the paste function. The dots are the values you want to concatenate. The SEP keyword is for the separator that you want to use in between the concatenated strings. And collapse is an optional field here which is used in case of vector strings. So here we have X variable that contains 3 different strings we want to join together. The words hello, world, and exclamation mark. So the separator I'm using is an empty space. Now let's run this code. And again I will execute the line 27 to print the value of X. And here you can see we get a complete concatenated string which says hello world. Here we are concatenating the values of variable x1, x2 and x3 with the string are all happy. Now to remind you, we have already declared 3 variables x1, x2 and x3 as can be seen in the global environment window. Let's run this code and again print y. So here we get the concatenated string which says Olivia, John, William are all happy. This time here we have declared a vector variable x4 and stored the 3 names in vector x4. Let's say we want to print the concatenated strings separately, like Olivia is happy, John is happy, and William is happy. So for that, you will need to write the code as can be seen here in line 37. So what this will do is, for all the elements in x4, it will print the sentence individually. Let's run the line 37 and 38. So here you can see the printed variable y1 that contains 3 different sentences. Now let's see the use of the collapse keyword in the paste function. So here it is, and this time I will print the same string as for the previous case, y1. But y2 here will have a separator dash dash in between them. So let's run this code. So here you see, we get the same result but with separators between them. Now here we have declared 2 different strings, vectors z1 and z2. And here z1 contains 2 elements, that is please bring me and a few. Whereas z2 contains 2 elements, some vegetables and fruits. And we want the paste function to actually join the 2 vectors for us using the collapse as AND. So what the paste function will do here is that it joins the first element of z1 with first element of z2, then inserts the collapse word we have given here, which is AND in our case, and then joins the second element of z1 with second element of z2. Let's run the line from z1 to z2. To run the line, we select the lines from 47 to 50 and then press Ctrl plus Enter key. So this runs all the selected lines at once, and here Z is now printed and it gives us the string, please bring me some vegetables and a few fruits. So this is what we expected as well. So I hope you have got an understanding of how to concatenate the strings in R, and in our next lab session we will see how to manipulate strings in R. Hi, and welcome to this lab session. In this lab, we will learn about string manipulation. String manipulation or string handling is the process of changing, parsing, slicing, pasting, or analyzing strings. Here we have a variable x with the string William is happy today. If I print the variable x, you can see the same string printed here. So the first thing we will do is convert all the letters of the string in variable x to uppercase. So for this, we use the function toUpper and pass the string variable to it. So you can see that all the letters are converted to uppercase letters. In the same way, you can convert the letters to lowercase using the toLower function, as can be seen here in line 13. Let's run it. And here you see that all the letter cases are now changed to lowercase. Alright, let's see how to replace a character in a string. So replacing a character means that you replace the existing letter in the string with a letter of your choice. We have variable x1. If you notice, we have uppercase letter A in the string. If we print the variable x1, we get Henry is a hard worker, he owns a house and a car, having all single A's in uppercase. So to replace those uppercase A with lowercase, we use the function chartr, that is character transform. If you see in line 19, the syntax for function chartr is that you give the first input, which is the letter or say the character that needs to be replaced. Next input is the letter that we replaced with the first input we just gave. And the third input is the variable in which the string exists for which you want to replace the letters. So here we want to replace uppercase A with a lowercase a in the string contained in the variable x1. Let's run the code. So you see that all the uppercase A's are replaced with lowercase a. This is how we change a single character in a string. In this example, let's see how you can replace multiple characters in a string. Let's say the string was mistyped or some keys were not working on the keyboard. So what you want next is to replace the mistyped characters with the incorrect ones. As you can see in line 23, we are using the chartr function. Now in the first input you see old equals dz, and in second input we see new equals ta, which means that we want to replace the character d with t and character z with character a in the variable y. Now let's run the code. Here we see the mistyped string, and now you see that we get the string with the correct letter replaced. Tomorrow I plan to learn about textual analysis. It's not necessary to write the word old and new with the function chartr. Here in the line 25, you can see we have a variable z, which has a string with mistyped characters. We want to replace the character D with I and character Q with O. Now let's run the code. So here we got the replaced letters and the string is corrected now, which says I will go to market tomorrow. Alright, now let's have a look at how to create or generate abbreviations in R. An abbreviation is a shortened form of a word or a phrase by any method. So it may consist of a group of letters or word taken from the full version of the word or phrase. Okay, so here I have declared a vector with name cities that contains some city names. Now to abbreviate these city names with default string settings, we use the function abbreviation and pass the vector variable which contains the city names. Let's run the line 34. So here you see we get the abbreviated names BRLN for Berlin and PARS for Paris, and we have other as well. Let's say we have a case where we want our abbreviated name to be of 2 characters only. So to limit the numbers of characters in the abbreviation, we use the second argument, which is min length. And in this case, we have minimum length equals 2. Now let's run the code. So you see, this time the abbreviated words are of 2 characters only. We have BR now for Berlin and PR for Paris, and so on. So this was the lesson on how to manipulate strings in R. We will continue with some more manipulation in the next lesson. Alright, so let's continue where we left off in the last session. String manipulation also involves the process of extracting and replacing the strings. Here we have a variable x2 in which we have Henry puts in all his efforts. To extract the characters from the string, we use the function substr. For its syntax, you give the string variable, the start and the stop index number for which you want the characters to be extracted. Now in line 48, what we are extracting is the characters from index number 22 to 27. Let's run it. So we get the substring good with spaces which is at the index 22 to 27. You can also replace the substring with a new string. Now let's have a look at the code on line 50. Here we are extracting the same substring good and replacing it with bad, including the spaces. Print the updated variable. And here you go. We now have the string in x2 as Henry puts in all his bad efforts. Next in we have is the substring function. This extracts and gives you all the characters from the given index number. For this case, we have given the index number 22, so this will return you all the characters from index number 22 till the end. So we get the string good efforts. Now let's look at how you can split the string. So for that we use the strSplit function for this purpose. We have the same text in variable x4 this time. Now I will split the string using the strSplit, which says split each word in the string x4 when there are spaces. And the result is stored in variable y1. And now when I print y1, you see we get a list of all the words in our string. Also, if I check the class of the variable y1, you see it is a list. Let's have a look here at the credit card example. So we have a credit card number in a variable crdt_crd. Let's see variable. So I will now split the group of numbers from variable credit card with the split match as a dash. So what this line 67 will do is split the strings for card number where it sees the dashes. Let's run it and see variable. So here we have a list of 4 different groups of numbers that were available in the credit card variable. Alright, let's see what happens when we split a string with a single word. So we have the word Mason and we will split it into characters. Here we get the individual letters in the word Mason. There might be cases where you don't want your string to be splitted into a list, but instead you would prefer it to be a string vector. Here we have x4 that contains the string Henry puts in all his good efforts. This time we will use str split function but inside the function unlist. Now let's run it. So the y2 is a vector of all the words in the string. And if I quickly check the class of y2, it's character. Moving on further, we have a variable string1 and it contains the string he have a big house. Let's say we want to replace the word big with small. So this can be done using the sub function. So as you can see in line 84, we use the sub function saying that replace big with small in the variable string str1. So you can see that the sentence is changed to he have a small house. This was all for string manipulation. I hope you have got a clear understanding on how to manipulate strings in R. And in our next lab session, we will look at what are strings patterns and how to deal with them in R. In this lab session, we will look at how you can search for a pattern in a string in R language. Pattern can be any character, a word within the sentence, or a sequence of characters that you want to search for in a string. Here we have a variable x with string I have 3 apples. So we will use the grep function over here. The grep function is a case-sensitive function and gives an output when a search pattern is found. In line 10, we are looking for patterns, or you can say search for the letter A. When I run this command, so you see we have the result 1. This is not the logical one, but this one means that we searched for a single variable x and the letter A exists in it. Don't worry, this will be clear to you when we see the next example. We have a vector variable with some fruits name in it. First, we will look for the pattern capital A in the vector variable fruits. It returns 1. This means that the letter uppercase A exists in the first value, which is apples. Next, I will search for lowercase a. This time it returns 2, 3 and 5, which means that the lowercase a is present in the second element, which is bananas, the third element, which is pears, and the fifth element, which is oranges. Similarly, let's search for letter case n. This returns 2, 4 and 5 because the letter lowercase n is present in fruit names present at these indexes. To get the elements instead of the index numbers in which the search pattern occurs, the same grep function can be used. So for the same vector fruits, let's search again for the letter A. If you see line 20, this time with same code line, we have added value equals true. So this will return you the value itself where the letter A occurs. It returns apples because the letter uppercase A occurs in apples only. Similarly, next in line 21, we are looking for lowercase a. And this time, it returns 3 values where lowercase a occurs: bananas, pears, and oranges. If we want the grep function to ignore the letter case, you search for the required pattern and use the keyword ignore.case equals true. So this ignores the letter case and searches for whatever string pattern you are looking for. In line 24, you can see we are looking for character A search. This time it returns 1, 2, 3 and 5 because letter A is present in these indexes values. Similarly, I am now looking for the string pattern and. So this returns me 2 and 5 because the string pattern and is present in bananas and oranges. There is another function grepl which does the same thing as grep, but it returns logical values in a vector format. So for the same vector fruits, let's search for the pattern n. It shows true on index number 2, 3 and 5, which shows that n is present in second, third and fifth element in the vector fruit. Alright, so that was for the pattern finding. Let's see another function, regexpr, that is regular expression. The function finds the first position in the vector string where the match is found. In line 35, we are looking for character lowercase a. It returns -1, 2, 3, -1, and 3. This means that for the first element, the letter lowercase a does not exist, so it returns -1. For the second element, bananas, the letter a starts at the second position. And for the pears, it starts at third position. Then for melon, again, a -1 because it does not contain the letter a. And for the oranges, it starts at position 3. Similarly, let's search for the pattern and. So it returns -1, 2, -1, -1, and 3, which is self-explanatory. We can also ignore the letter case here as well with the same statement, ignore.case equals true. So you see in line 39, let's run it, and it returns 1, 2, 3, -1, and 3. So this is how you can search for the string patterns in a string in our language. In our next section, we will start with the control structure in our programming language. Hi and welcome to this lab session. In this lab session, we will learn how to print your output in our language and what are the different functions to perform this task. We have declared a variable x which says skill curve. Now we have written here two common methods of printing a variable. In line number 7, if you see, the variable is written directly. If a user wants to quickly have a look at the variable value, you just write the variable name and run it. Here you can see that it displays the x variable value. Another way is to use the print function as in line number 8. So the print function takes the input that needs to be printed. Now run the code. So we get the same output, and this was a string value. Now in the same way, you can also print the numeric values. Here 43 is assigned to variable y, and then we print it. You can also directly print the values by passing it in the print function. Like we print here Williams a string value. Then we print the value 2L, which is an integer value, and it prints 2. Then we print the decimal value 32.14, which is double. Print function can also be used directly while concatenating the strings. Here we have a variable z to which we assign the string William. Next we have line 22 which says paste function. So value of z and the hard-coded string is a good boy needs to be joined together. Let's run it. So you see it prints the variable x first, which is William, then a space and followed by is a good boy. As you can see in line 23, if we use paste 0 instead of paste function, the output contains no space between the variable value and the hard-coded string. Let's run it. Now as you can see here, the output has no space between William and the string is a good boy. Now let's see the sprintf function in R. So when you want to print multiple data value types, so here I will execute line number 27 till 31, which takes in two variables and add them to the variable answer. So let's start with sprintf function. Here we use the %s in the string which says will be performed in the next command. So basically what happens is that instead of %s sign, the variable value sum is replaced. So when I execute the command, now here it prints sum will be performed in the next command. Now let's move on to the line number 37. Here we wish to print the statement which displays the numbers, the operator performed, and its results. So we have first %s in the sprintf statement, which belongs to the first argument, that is operator. Then %f, which is for number 1. Next %d, which is for integer value, that is 20l. And finally %f for answer variable. So we get the output as sum of 5.50 and 20 is 25.50. Now there is another function to print, which is the cat function. The function is used when you wish to use the conventional C keywords like \t for tab and \n for new line and etc. So here I have a variable with string memory. In line number 44, I will print the my message variable with a tab. So we get the output as memory followed by tab and then is full. In the same way, we use the \n and we get the output as memory, then a new line and is full. Alright, next we will see the output function where you can print the output in a text file. So here I have the variable my_name, which has my name Olivia, and then I use the write.table function to write my_name variable in a text file, which will be created with the name_file.txt. Control plus enter. So if you open up your current working directory in the bottom right window, you will find this file here, this file, name_file.txt. So this is how you print your outputs in R using multiple methods. And next we will see the user input function in our next lab session.
Hi and welcome to this lab session. In this lab lesson, we will look at how to perform operators in R language. So we have 4 different types of binary operators, and in this lab, we will perform some of the arithmetic operators. Let's begin by declaring the 2 variables over here. So I have declared x and y here with values 6 and 3. The first operation I am performing here is the multiplication operation in line 18 and storing the result in variable mult. So here I run it, and the product result for x and y, which is 18. Next, we perform the addition operation. So here we are adding x and y and storing the result in variable add. In the same way, we will perform the subtraction and division operations and store the result in their respective variables. Let me execute these lines. And here we get the results. The next operation we have is the power operator. In this operation, we are calculating the x raised to the power y value and storing it in the variable PWR, that is power. So let's run it. And here we get the result for the power operator as well. Okay, so when you want the remainder of the division operation, we use this sign, the double % sign. So over here, I will calculate the remainder for division of A and B. So let me run the line 42 till 44. So we get the result as 2, which is the remainder you get when you divide 5 by 3. Here I will perform the same operator on variables x and y in line number 46. So we already have variables x and y declared. So we get the answer 0, because you get a 0 remainder when dividing 6 by 3. Alright, so here is another operator we have. This operator performs the division and returns the whole number value to you. So we have the values already declared for A and B. Let's run line 51 and we get the answer as 1. If you had performed the simple division, it would return 1.666 but just returning the whole number value, it is 1. So this is how we perform these binary operations in R. I hope you have got an understanding on how to perform some of the arithmetic operations in R. We will be looking at more operators in our upcoming sections as well. And in our next lab session, we will see how to use the logical operators in R.
Hello and welcome to this lab session. In this lab, we will look at the logical operators in R. We have previously had a look at these while discussing the logical data types. So logical operators are used to combine two or more conditions and perform the logical operations. So here we have two variables, number 1 and number 2. So we have a true value and a false value. Let's compute its OR operation. We get true, which is obvious as the OR operation of a true and a false value is true itself. Next, we perform the AND operation. So here we get the answer as false. In the same way, logical operators can be performed on the vectors as well. So here we have vect1 having values false, true, 0 and 60. Next vector is vect2 having values as true, true, false and true. Now you might be wondering that we are talking about the logical vectors and vector vect1 has a non-logical value 60. This actually to let you know that the values greater than 0 in R is always considered as true while performing logical operations. Now let's perform our first operation. When you perform the logical operations between the vectors, you use a single sign. As we are performing OR operation between the vect1 and vect2, so you can see a single OR operator sign being used here. Next is the AND operator, and here we get the result for the AND operator as well. So this is how you perform the logical operations in R, and in our next lab session we will have a look at the control structures in R. Hi and welcome to this section where we will look at control structures in R. These are very important because in any programming language you will always want to have control over your program, when to start it, when to stop it, and what conditions to check and all that stuff. Let's begin with the control structures. A control structure is like a block of programming that analyzes variables and chooses a direction in which to go based on given parameters. The term flow control details the direction the program takes, which way program control flows. Hence, it is the basic decision-making process in computing. Here are the listed control structures that we will be going through in this lesson. Let's start with the if condition. If is the simplest control structure as you see in the visual. The if structure evaluates the condition. If the condition is true, the code following the if is executed. Otherwise, the code following the if is ignored, and the code after if structure is executed. Unlike simple if structure, if-else structure has two parts, the if and the else. In this variation of the if statement, if the condition is true, then the code following the if is executed. If the condition is false, the code following the else block is executed. And finally, code after the if-else structure is executed. Next, we have the for loop. For is the easiest loop structure that repeats a single line or multiple lines of code for a specified number of times. On every iteration, the loop condition is tested. If the condition is true, loop body is executed, otherwise the loop body is skipped, and next line of code after the for loop is executed. In for loop, we use the loop counter variable to keep track of the current value loop that is tested against the loop condition. The value of the loop counter variable increments or decrements on every iteration. Switch statement in C tests the value of a variable and compares it with multiple cases. Once the case match is found, a block of statements associated with that particular case is executed. Each case in a block of a switch has a different name or number which is referred to as an identifier. Unlike for loop, in while we don't have a loop counter variable. In the while loop, there is no concept of increment or decrement. We use while loop in situations where we don't know for how many times we need to repeat a statement or a block of code. Repeat is the loop which can be iterated many numbers of times, but there is no exit condition to come out from the loop. So the break statement is used to exit from the loop. Break statement can be used in any type of loop to exit from the loop. Next statement is used to skip the current iteration without executing the further statements and continues the next iteration cycle without terminating the loop. Now let's move on to the RStudio IDE to look at these control structures in detail. Hello and welcome to this lab session. In this lesson, we will see how if and if-else statements work in R. Here we have assigned two numbers 22 and 80 to two variables. So a simple comparison over here in line 9. If the first number is less than the second number, as the case is, so the output should be first number is smaller than the second number. Select the lines from 9 to 12 and then press Ctrl plus Enter. So here you can see we get the expected output. Next we have the positive number testing code here. So 3 is assigned to variable y. And let's select line 17 to 20 and run it. So here you can see that as 3 is greater than 0, so output gives us y is a positive number. Likewise, you can perform your own tests as needed. In the same way, we can also make a test for both positive and negative numbers at a time using the if-else statement. So here we have minus 20 assigned to x2. So whenever the value of x2 is greater than 0, it will print the number is positive, and if it is negative, it will print that the number is negative. Now select the lines 25 to 31 and run it. So here is the expected output. Alright, so let's have a deep dive into this. So we need a code that will have a salary variable, and according to the given ranges, wherever the salary value lies, it will return that particular output. So the range we have is if the salary is between $0 to $200, the output will be less salary. If it is between $201 to $500, it will return average salary. And if it is above 500, the output will be the handsome salary. So here we have the code for it. The variable has value 150. Select the lines 42 to 51 and run it. So it gives us the status of the less salary. You can have the code from the reference section and try it out with different values of variable salary. There is another statement which is also known as direct if-else. We will have a look at it in our next lab session. Hello and welcome back to another lesson on direct if-else statements in R. We have already seen the if and the if-else statements. Now, the syntax for direct if-else statements can be seen here. So in this case, you write if-else and in the bracket you have the test expression. Then if the test expression is valid or true, the X code is executed, else the Y code is executed. So let's compare a value with 10, and if the input is less than 10, the less than 10 statement will be printed, else the greater than 10 statement will be printed. Let's run the code by selecting the lines 11 and 12. So here we can see the output says greater than 10 as 12 is greater than 10. Alright, we can also use the if-else to get a vector output. So select line number 16 and run it. So now here I have generated a vectors of numbers from 10, 1 to 10. Now here in the line number 18, I have a code that checks if the number is odd or even, and then generates a vector output accordingly. Let's run it. So you see it gives a vector output showing the odd and even status for the sequence of numbers. Alright, now let's move on to our next use case example. You have seen the login process of many software, and here we will now take a user input, and if the user inputs a correct password message will be displayed. So now run the line number 22. So in the console I will enter password, admin only. Let's see what it says. Now run the line number 22. Now it says incorrect password. So again I will run line number 22, and this time I will enter password admin skill, and let's run the. So you see it says correct password as the password matches. Okay, so we have previously seen how to create a vector of even and odd numbers detected in a sequence from 1 to 10. Now here is in this example, we will create a vector of random numbers. So we have 5, 8, 10 and 20. Let's run the line number 27, and this time if the if-else statement will calculate the square of each values in the vector, and the test condition is that if the square of the value is greater than 65, the output will be 1, else it will be 0. Let's run this, and if I show you the value of y1, so here you see we get 0, 0, 1 and 1, because the square of the last two values 10 and 20 is greater than 65, so we get two ones. So this is how we use the if-else statement in R, and in our next lab session we will look at the for statements in R.
Hello and welcome to this lab session. In this lab we will look at how to use the for loops in R. So the syntax of for loop is you give a sequence of from where to start and end the loop. This basically iterates the codes within the for loop for the assigned number of times. Let's have a look at the code here. So this says that the for loop will start from 1 to 5 and the variable is x here, which keeps the track of the count. So when you run it, it will start the loop from 1 to 5, which will run 5 times. And each time the loop runs, the value of x will be printed. Let's select the line from 9 to 12 and run it. So you see it prints the values from 1 to 5. So the print statement was executed 5 times inside the loop. Alright, so in our next example, we have declared a vector here with some random values. So this time we will print the elements of this vector, my_vect, using the for loop. So what this for loop does here is access the elements of the vector and print it for the total number of elements in the vector. Select the statements from 15 to 18 and run it. Here it prints all the elements. Alright, so here we will print the square of the values from 1 to 5 using the for loop. Let's select the lines 22 to 25 and run it. For loop can also be used to store some values in a vector.
So here I have declared an empty vector in line 29 with name save_vect. Inside the for loop, we give the index for I to start from 1 to 5. And inside the loop, as you can see, we save the square of the values in vector save_vect. Now select the lines 29 to 33 and run the code. So the loop is executed and we can see some values in the workspace for vector my_vect. Let's see the values in it. Here we have the square of the values from 1 to 5. So this is how the for loop works in R, and in our next lab session we will look at switch statements.
Hello and welcome to this lab session. In this lesson we will look at how the switch statements works in R. If we talk about the syntax of switch statements, so here we have the expression as the first argument followed by the n number of cases. So the expression means which case you want to select out of multiple cases stated in the switch statement. Let's have a look at the code on line number 9. Here we want to assign a value to x using the switch statement. So the switch statement says expression is 2, which means out of 4 cases listed here, we will select the second one, which says string 2. Let's run the code and then print the value of x. So here it gives the output 2. Now we have another example. Here you can also select using the character value, but for this we need to assign a character key to each case as well. Here if you see, we want to switch to select the case with key R. And then we have multiple cases. First one is assign key R for red, then Y for yellow and G for green. Let's run the code and see the color name output. So you see the output shows red as we selected R from our cases. The indexing of switch cases by default starts from 1. So here you see we are trying to select the case 0 as the case starts by default from number 1 and at the back end. So it will give us a null value. Let's run the line number 15 and then 16. So here you see we get a null value. Now let's have a look at this calculator example. So here we will ask for 2 user inputs value from user and store them in number 1 and number 2 as numeric values. Then as a third input, we will ask the user which operation they want to perform. On correct selection, the respective operation will be performed and output will be displayed. So let's run the line number 19. And here we enter value 12. Now we run line number 20 and here we enter number 2. I will select the multiplication operator here after running the code. Now select line 22 to 27 and run it. So it gives the output. The answer for 12 into 2 is 24. This is how we use the switch case statements in R, and in our next lab session we will look at while loop in R. Hello and welcome to this lab session. In this lab we will look at while loops in R. While loops are used to loop until a specific condition is met. Here we have assigned a variable x with value 1. Inside the while loop, we check for the expression if x is less than 8. So till the condition meets, the statement inside the while loop executes. Inside the loop, we are printing the value of x and the string welcome to RStudio. And after that, we increment the value of x by 1 each time. So what will happen is that the print statement will be executed 7 times. As while loop always checks for the value of x, and during execution of while loop, the x is also incremented by 1. Now we will run the line from 12 to 16. Here is the result as expected. The string is printed 7 times. While loop can also be used as an infinite loop. There may be cases where you want some statements of your code to run all the time. If that is the case, we simply write true or 1 inside the while loop. This tells the while loop to execute all the time. So here we will print the same string, and also we will run the code and see the value for n as well. Now we will run the lines 19 to 23. So you see the code goes into an infinite loop, running and incrementing the value of n. To stop it, just press the escape key by clicking on the console. We can stop the loop using some condition and a break statement. I will leave that for our lesson on break statements, and in our next lab session we will learn about repeat and break statements. Hello and welcome to this lab session. In this lesson we will learn using repeat loops and the break statements. A repeat loop is used anytime you want to execute one or more statements repeatedly for some number of times. The statements to be repeated are preceded by one of the repeat statements. As you can see here, we have assigned 1 to variable x. Next we have a repeat statement and some lines of code in the loop. So here we will print the value of x incremented by 1 and the string welcome to RStudio. And in there, if the value of x is greater than 8, break statement will be executed. So a break statement stops the program process and exits the loop. Let's run the line from 9 till 16. So you can see that the code executes and print the string 8 times. Let's see how to use the break statement inside a for loop. Here we are printing the values from 1 to 100, but wait, if the value of I is greater than 7, the break condition will be executed. And the loop stopped from further execution and the string break the for loop will be printed. Now let's run the code from line number 19 to 26. So here is the output as we discussed. Next we have the same infinite loop we discussed in the last session. This time we will break the infinite while loop. So here we have set a condition. When the value of n greater than 1000, the loop should be stopped and no further execution shall take place. Let's run the code from line 30 to line 37. So here you see as the value reaches 1000, the loop is stopped with the help of a break statement. I hope you have got an understanding on how to use the repeat loop and break statement. In our next lab session, we will look at the next statements in R. Hello and welcome to this lab session. In this lesson, we will learn how to use the next statement in R. The next statement is used to skip the execution in a sequence of steps performed in a loop. Here we have a for loop with range from 1 to 10. We are interested in printing the numbers from 1 to 10 except for number 6 in the sequence. So for that we have the if condition with the next in here. So the code on execution will start printing 1, 2, 3, 4, 5, and when it sees there is a 6, it goes to the next command. The next statement will skip it to the next number and then we will get 7, 8, 9 and 10. Let's run the code. So we have all numbers from 1 to 10 except 6. Let's quickly have a look at another program. Here we are to print the sequence of even numbers from 1 to 10. Let's quickly have a look at another program. Here we are to print the sequence of even numbers from 1 to 10. So we have assigned the variable x a value 0. In the for loop, we will increment x with 2 for 5 times. That gives us the first 5 even numbers in the sequence from 1 to 10. And then there is a condition that if x is 2, skip it with the help of the next statement. Alright, so let me just run the code for you. So here you see we get the values 4, 6, 8 and 10. This is how we use the next statements in R. So this is it for this section. I hope you have got an understanding of control structures in R, and we will be using it extensively in our upcoming sections. So see you in the next lesson. Hello and welcome to this lab session. In this lab session, we will look at functions in R, how you can make your custom functions, and what are the built-in functions. A function is a set of statements organized together to perform a specific task. R has a large number of built-in functions, and the user can create their own functions as well. In R, a function is an object, so the R interpreter is able to pass control to the function, along with arguments that may be necessary for the function to accomplish the actions. The function in turn performs its task and returns control to the interpreter. Let's have a look at how to create user-defined functions in R. Here is the syntax for creating a function. So first we give a function name, which is of user choice. Then we give the keyword function so that the R interpreter knows that a function is declared. Then if the function is based on input arguments, we assign the arguments, else we leave it empty. And inside the function body, we declare the code statements that will be executed when the function is called. So here we have a requirement to create a function to calculate the square of the values. The values must be from 1 to x, where this x value will be an argument that the user will provide. So here the function name is square function, and the function takes a single argument x. Now select the line 17 to 22 and execute it. If you notice in the global environment window, this time you see a new thing that is a function heading. This is because we have declared a function, and the R interpreter differentiates the variables and the function in the workspace. Okay, so in line 24, I am calling this function that I created with the name square function with an argument 5 in it. What I am expecting to get on execution is the square of the values printed from 1 to 5. Now let's run it. Great, this is what we expected. Again I will call the function, and this time I will give argument value as 10. Let's run it. So we get the squares of values from 1 to 10. You don't need to run the function code lines again and again. Once it is executed in session, you can always call it using its name. Now this time we will create a function with no input arguments. So this means that the values will be hard-coded. So here I have given a function name as sq function, short for square, and in the function body I am interested in having the square of values from 1 to 5. Whenever we call this function, we will always get a square of values from 1 to 5. Now run the code and select the lines 30 to 34. So you see another function appears in the workspace. Now let's call it, and we will run the line number 36. So we get the expected output. Alright, let's have a look at the function where we have multiple input arguments. So here I have my function, and the function has three arguments, d, e, and f. We will calculate here the expression d plus e in the bracket minus f. And the computed value for this expression is saved in a variable result, and then we will print this. Now let's run the function first. So for this example, I will have the value for d as 5, e as 5, and f as 2. Now let's call the function with these values. Run line 46. So here you see we get the answer as 8. You can enter different values and try it out. Now let's have a look at the user function for strings as well. So here we have a function which will add the title Mr. with the names provided as an argument. So here our function name is title function. Inside the function we have used the paste function to add the title with the input name and then print this. So let's run the function first. I will call the function first with the name Steve. Now run it. And you see the title Mr. added with the name Steve. Same is the case with William. These were the examples of user-defined functions that a user declares. There are some other built-in functions as well. We have seen most of them in our earlier sections as well. And here are the listed examples. With this, I hope you have got an understanding of how functions work in R, and in our next lab session, we will have a look at math functions. Hello, and welcome to this lab session. In this lab session, we will look at some maths function in R. R comes with a whole set of mathematical functions, and it naturally contains a whole set of functions that you would find on a technical calculator as well. All these functions are vectorized, so you can use them on complete vectors. So I have declared here three set of variables: the x variable and the x negative variable that contains a single value that is positive and negative respectively. Next, I have a x vector that has values from 1 to 10 and x negative vector that has values from -1 to -10. Let's run these variables. Now let's perform the absolute function. Absolute method in R programming is used to get the absolute value, that is, positive value does not change and negative value converted into positive value. Let's see the absolute function for each of these variables. So first I will do it for x variable. So here we get the same positive value with no change. Now let's do it for x negative variable. Here it returns positive value, that is 11.2, and it converts negative values to positive. Now absolute function can also be performed on vectors. Let's run line 14 and 15. So you see it returns a complete vector with positive values. Then we have the log function, which performs the log of x with respect to the base y. If the base value is not provided, it completes the natural log of the input value arguments. Let's calculate log for a single value and the vector as well. Let's run line number 21 and 22. So you see for the vector, it returns a vector with its log values. Next, we have the exponential function. This function calculates the exponential of the input values. Let's run it for the x variable and vector. Here is the answer to the vector and the single variable itself. Next, we have the factorial function, which calculates the multiplied value from 1 to x, which is the provided input. Let's run line 32 and 33. So here we get the answers for both and you see it returns the vector results for the vector input. Next is the sum function. This function calculates the sum of the input values. For vectors, it gives a single output summing all the values in the vector. Let's run line number 37 and 38. Here is the sum for both cases. You can also add some more values to add in the vector total. Like here in line number 39, I will add 5 to the total sum of the values in x vector. So this is how you perform math functions. There are many other math operations as well, but we have discussed a few here. In our next lesson, we will learn about statistical functions in R. Hello and welcome to this lab session. In this lab, we will work around some of the mostly used statistical functions in RStudio. Let's begin by declaring a vector x with some random values in it. First, we have the median function. The median is the value separating the higher half from the lower half of a data sample. Let's run the line number 9 and see the output. Okay, next we have is the mean. So mean is the average value in a collection of numbers. Let's run it and see the result. Then we have the var function, which calculates the estimated variance of the dataset. Let's calculate it for the vector x. Okay, next is the standard deviation function. The standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that the values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wider range. Let's check it out for our case, and we will run line number 20, and it is a very small value. Then we have the sort function. This is used to arrange the values in the ascending order. Let's check it, and we will run line number 23. So we can see that all the values are arranged in ascending order. You can also check for the nth smallest number in the vector dataset. In line 26, we are looking for the first smallest number. While looking at the dataset, we can say it's 2. Let's run line 26 and check it. So the answer is 2. Next, let's also see the second smallest value in the dataset, and it's 3. So this is how we perform some statistical functions on a dataset. We will be performing them in detail in our future sections. So I hope you have got an idea of how functions work in R and what are the maths and statics function used in R. Hello and welcome to this section on overview to data structures in R. In this lecture, we will see what are data structures in R and how do we use them in our language. And in the next section, we will have practicals on these. R is an object-oriented language and all data structures are objects. R does not provide programmers direct access to memory, and all data must be accessed via symbols or variables that refer to objects. Since vectorized operation is an important aspect of R, so R does not have any scalars. The most basic data structure is a vector, which is a sequence of data items. Thus, a single integer value is treated as an integer vector of unit length. The most versatile data structure is a list, while the most common one used for data analysis is the data frame. Here are the data structures listed that are used in R. So we have the vectors, arrays, factors, matrices, lists, and data frames. Let's discuss each one of them in detail. Before we go discussing each one of them individually, let's have a quick look at this table. So we have two categories when talking about the data structures: the homogeneous and the heterogeneous. The homogeneous data structures contain similar types of data, such as integers or double values. Homogeneous data structures are used in matrices as well as vectors and arrays. The heterogeneous data structure, on the other hand, contain non-similar types of data. Heterogeneous data structures are used in lists and data frames. Vectors are single-dimensional. Homogeneous data structures A vector is the basic data structure in R, or we can say vectors are the most basic R data objects. There are 6 types of atomic vectors such as logical, integer, character, double, and raw. A vector is a collection of elements which is most commonly of mode character, integer, logical, or numeric. So to create a vector, use the C function. We have already created vectors in previous lab examples. A matrix is an R object in which the elements are arranged in a two-dimensional rectangular layout. They have rows and columns. In the matrix, elements of the same atomic types are contained. For mathematical calculation, this can use a matrix containing the numeric element. A matrix is created with the help of the matrix function in R. If you see at the syntax in here, the data is the input values in the matrix given as a vector. N-raw is the number of rows. N-col is the number of columns. By-raw is the logical which tells the function to arrange the matrix row-wise. By default, it is set to false. And dim names is a list of the names of the rows, columns that has been created. Arrays are n-dimensional, mostly 3-dimensional, homogeneous data structures. They are collections of matrices stacked one on top of the other in layers. You can create an array using the array function. Given is the syntax for it, where array underscore name is the name of the array. Data is the data that is filled inside the array. Dim is a vector containing the dimensions of the array. And dim names, that is dimension names, is a list containing the names of the rows, columns, and matrices inside the array. Lists are heterogeneous data structures. They are very similar to vectors, except they can store data of different types. Different columns can contain different lengths. So items of a list can be accessed using double square brackets. This is a recursive data type. Lists can contain other lists. So to create a list, we use the list function. Data frames are two-dimensional heterogeneous data structures. They are lists of the vectors of equal lengths. A data frame must have column names, and each row should have a unique name. Each column should have the same number of items, and each item in a single column should be of the same type. Also, different columns can have different data types. Factors are the data objects which are used to categorize the data and store it as levels. They can store both strings and integers. They are useful in the columns which have a limited number of unique values like male, female, and true, false, etc. They are useful in data analysis for statistical modeling. Factors are created using the factor function by taking a vector as input. Now let's move on to the practical sessions for these data structures we have discussed. Hello and welcome to this lab session. In this lab lesson, we will learn about the vector implementation in R. We have discussed the theory in the previous section on data structures. Now let's begin by creating vectors in R. Vectors must have all the elements of the same data types. There are multiple methods using which you can create vectors in R. Let's look at the first one. This is known as the C function method. Here I am creating a vector A with values 1, 2, 4, 7, and 8. Now run the codes at line 10 and 11. So you see in the environment variable as well that the vector A with 5 elements have been created. Now to check the type of a vector, we use the function typeof. Let's check the type of this vector here. So it is a double type vector. We can also check the length of the vector using the length function. So the length of the vector is 5. Another method to create the vector is using the colon operator. I will create a vector here with name B, and its element will be numbers from 1 to 8. This is useful when you want a vector to store numbers in a sequence. Let's run it. So you can see in the workspace we have 8 element vector B is created. Alright, let's check the other method of creating vectors. Here we have the sequence function. So I will create a vector C using this function. The sequence function takes in 3 arguments. The starting number, which is 1 in our case, the ending number, which is 5, and the step size for each consecutive number, which is 0.5 for our case. Let's run it. So we get a 9-element vector starting from 1 to 5 with 0.5 interval. One more way of creating vectors in R is using the assign function. We give 2 inputs to this function. As you can see here, we are interested in creating a vector D with vector elements as 5, 7, 20, 17 and 25. Let's run line 31 and 32. So we get the 5 elements. These were a few methods of creating vectors in R. Let's now look at some patterns when creating vectors. If you want your elements in your vector to repeat for n numbers of time, we use the repeat function. Here we will create a vector v underscore rep with elements 2, 8 and 9 that will repeat 4 times in a vector. Let's run the code. So here you can see that the elements 2, 8, 9 repeat 4 times in vector, and the length of this vector is 12, as can be seen here in the global environment window. Let's discuss the 2 important vectors. First is the empty vector. So to create an empty vector, just leave the C brackets empty. Now run the code. So you can see that the vector is null. The other important vector is the random number elements vector. So here I will create a vector with random numbers as v underscore random. The function used here is random uniform function. The random uniform function takes 3 arguments. The first one is the total number of the elements, second is the starting number, and third is the end number. Let's run the code 47 and 48. So you see it gives you random numbers in decimal point. Using the previous knowledge, we can convert these decimal values to the whole number. So here I will use the function as.integer. So now you see all the values are converted into whole numbers. This is how you create vectors in R programming language. And in our next lab session, we will look at vectors type in R. Hello and welcome to this lab session. In this lesson, we will learn about vector types in R. We already know that all the elements in a vector must be of the same data type, but what can be the data type for vectors? The first type we have is the numeric type. A vector with numeric type must contain all numeric values. Let's create vector v underscore num. Now run the line 6 and 7. So here we have a vector created, and the type of the vector is double, as we have all the numeric elements. Next, let's check the integer data type. So here we have the vector v underscore int, and here we have values 12, 14, 10, 7 and 9 with letter L, which represents that they are integer values. Now let's run the code. So here we have the vector and its type is integer. Then we have the logical type vector. Here I have created a vector with the name v underscore logical. We have the elements true, false, 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 true and true in here. Let's execute these lines of code and create this vector and check its type. So here we have the vector and its type is logical. Next we have the character type vector. I have named the vector as v underscore string. The elements in here are the names William, Steve, Olivia and Henry. Let's run the lines of codes. Let me select the lines 22 till 24 and run it. Then we have the last data type, which is complex data type. I have created a vector with the name v underscore complex. So we have the elements 5 plus 4i, 3 minus 2i, 1i and 5 plus 0i. Let's run the codes 27 to 29. And here we get the data type as complex for this vector. So these are the 5 different data types for which you can create the vectors in R. Next, we will look at vector operations in R. Hello and welcome to this lab session. In this lab lesson, we will learn about vector operations in R. We will cover the vector arithmetic operation in our upcoming lab lesson. And in this lesson, we will focus at combining vectors and coercion of vectors in R. So we have here two vectors v1 and v2. v1 has element 1, 3, 5, 7 and 9, whereas v2 has element 2, 4, 6, 8 and 10. We will combine vectors v1 and v2 into a new vector v3. So here I have written v3 equals c bracket v1 and v2. Let's run line 9 and 10. So here you see on printing the vector 3, the elements of v1 are printed first and then elements of v2. If you want to sort the elements of the vector in ascending order, you can use the sort function. So here on executing sort v3, we get the sorted output from 1 to 10. You can also add other elements in the combined vector, like here I am adding 20 and 30 between the elements of v1 and v2. So let's execute line 13 and 14. So we see that 20 and 30 are inserted between the elements of v1 and v2. Next, we have the coercion in vectors. So what happens if you try to add different data type elements in a vector? So let's look here in vector v5. I have added 12, false, 4, 3 plus 2i and RStudio. So I have all the 5 different types of data type elements in a single vector. So what will R do to this vector? The R interpreter basically converts the data type of all the elements as per the priority, which I have listed for you in line 18. So if we have all the 5 data types, R will convert the vector data type to character. Let me run code lines 20 to 22. And here you see it shows type as character. And also you will notice that all the elements in console are printed as characters. Let me quickly show you another coercion example. So here in v6, here I have numeric and integer data type. So if you look at the priority here at line 18, R should change the vector data type to double. Let's run the code line 24 and 25. And you can see that the vector is changed to double type. So these were the basic operations on vectors. In our next lab session, we will look at vector indexing in R. Hello and welcome to this lab session. In this lesson, we will learn different ways about creating the matrices in R programming language. A matrix is a rectangular array or table of numbers, symbols or expressions arranged in a rows and columns. Let's start creating a matrix. Here we have the syntax to create in the RStudio. The data is the actual data that the matrix will contain. nRow and ncol are the number of rows and columns that you want in your created matrix. By_row is the logic condition where if it is true, all elements in the data will be indexed row-wise, else they will be created column-wise. And the dim names are the names that you want to assign to the rows and columns. Here in the line 11, I am going to create a matrix with data as numbers from 1 to 9. I want to create a 3 by 3 matrix, and since I haven't given the by_row condition here, so by default the elements will be stored in a column-wise order. Let's run this code. Here is the result as expected. Here the numbers in the square brackets are the rows having values comma 1, comma 2 and comma 3. Then we also have some values over here as the columns. So these are the row and column indexes for the matrix we just created. Next, I will create the same matrix with data as numbers from 1 to 9. But this time I will not tell the numbers of columns to the matrix function. By default, it automatically calculates the dimensions and generates the matrix. For both the created matrix, the data was stored column-wise. Now let's see how you can create the matrix, but this time in a row-wise format. So here I am creating the matrix again with the same data having numbers 1 to 9, and in the arguments to create the matrix, I have written by_row equals to true. So this is the matrix function to store the data row-wise. Let's run it. And here you can see that the output of the matrix is in the raw format. Then here I will declare the matrix with elements 1 to 9. Here I have only declared the number of rows equals to 3 this time. So R automatically detects that there are 9 elements and number of rows is 3. So it will declare a matrix of size 3 rows and 3 columns. Then here I will declare the elements from 1 to 12, only with giving rows count as 6. Next we have the same matrix from elements 1 to 12, but this time its by row argument is false, so this will declare the elements in a column-wise fashion. You can also name the rows and columns of your matrix. So here I am saving my matrix in a variable x, and then I have used the arguments dim names with the list of vectors containing the row and column. I will assign the rows as R1, R2 and R3, while the column names as C1, C2 and C3. Let's run lines 36 and 37. Here the matrix is created with our given names. Let's check the class. So the class is matrix array. Okay, so if you want to see the order of the matrix, we use the dim function. Let's run it. So dimension of the matrix is 3 rows and 3 columns. To look for the dimension names that are the row and column names, and to change it directly, we use the functions call names and row names. So here let me run line 41 and 42. You can see the names here in the console. Let's say we want to change the names of the dimensions. That can be done easily by assigning a name of vector to call names or row names, just as can be seen here in line 44 and 45. So let me run line 42 to 46. Alright, so here is the matrix with updated names. You can also create a matrix in R using the cbind and rbind functions. For the first example, I have 2 vectors, and using the cbind, I will store the created matrix in a variable y. So the cbind functions binds the input vectors as columns and create the matrix. Let's run line 50 and 51. So you can see that the matrix is created in column-wise fashion. For the same vectors with rbind function, here the output matrix is generated in row-wise fashion. Okay, so last method I want to discuss for creating the vector is using the dim operator. So basically I have a vector here having these 6 values. Let me print it as well for you. So what I will do is change the dimensions of the vector. So this will convert the vector A to a matrix. So this will convert the vector A to a matrix of dimensions having 2 rows and 3 columns. Let's run it. And again let me print the matrix A, and you can also check the class and its matrix now. So I hope you have got an understanding of how to create a matrix in R. Next lesson will cover the topic on how to access your elements inside the matrix.
Hello and welcome to this lab session. In this lesson we will learn how to access components of matrices. I have declared a matrix X over here having 2 rows and 3 columns. I have also saved the result here in the form of comments. Now here you can see there are 2 rows and 3 columns. So when I talk about the element at index 1 row and 2nd column, it's 3. To access the components of a matrix in R is how I have written here at line number 14. Here I am trying to access the element present in the 1st row and 3rd column. The number before the comma inside the square brackets is the index for row, and after the comma is for column. Let's run it. So we get the element which is 5. In the same way, I will access the element at 1st row and 1st column. So this is 1. To access the complete matrix, you can directly print X or write X with empty indexes inside the square brackets. So here we get the complete matrix X here. Okay, so over here in line number 23, we are trying to access all the columns of row 2. The 2 here tells me to access the 2nd row, and the empty index after the comma shows to access all the columns. Let's run it. So here we get the complete row of the original matrix. The class of the return variable is integer. In the same way, you can also access the complete column. So here in line number 28, I will access all the rows of column 3. So as a result, I will get complete column 3 of the original matrix. Let's run it. So here we get the elements of column 3. And the class for the return variable is integer. If you want the column to be returned in the columnar format, just use the argument drop equals false. So this will keep it in its shape. Here I run it. And we get the same value 5 and 6 in a columnar shape. And the class for the z variable is matrix. The other method of accessing the matrix is using the vector indexing. Let me show you how it works. Let me first run the line and then I will explain to you. Let's first see the original matrix X here and then line number 39 result. Alright, so what we get as output I have written here in the comments. What are we trying to say here in line number 39 is we want to access the first row, first column element, then first row and third column element. After that we want to access the second row and first column element, and finally the second row and third column element. And this way you get the complete matrix on execution. Alright, so then you can also access your matrix using the logical indexing. So over here we have the matrix X, and in line number 48 we have used the logical indexing. So the number of vector arguments for rows and columns must be equal to their dimensions. Like I have 2 rows in my matrix, so I have used 2 vector elements for rows and 3 for columns. For cases where you don't give it, R will by default interpret it as true. Over here we have a raw vector having 2 true values, which means that the index 1 and 2. And in the column vector we have indices 1 and 3 as true. So what you will get are the elements of the first row, first column, first row and third column, second row and first column, and the second row and third column. And here I run it. So it returns us the respective values as we discussed. Next, we will see how you can access the matrix components using the dimension names of a matrix. So here I will first assign the column and row names to the matrix X. Now let's display the matrix. So we have the column and the row names here. And now I will access the elements using the dimension names. So in line 59, what I'm saying is that I want to access the R1 and C2 element, then R1 and C3 element, then R2 and C2 element, and finally R2 and C3 element. Let's run the code, and here you see we get the expected result. One more way of accessing the elements of a matrix is using the combination of integral indexing and logical indexing. So over here you can see we have the raw elements as 1 and 2, and the column elements true are 1 and 3. So what you will get are the elements of first row, first column, first row and third column, second row and first column, second row and third column. And here I run it. So it returns us the respective values as we discussed. The last method I'm going to discuss is the negative integral indexing. In this method, we have the rows as 1 and 2 selected, and the -3 in the column means that other than 3 or except the third column. So we will have the first and the second column elements. So let me run it for you. Here is the original matrix, and here is the access matrix elements. This is how we access the components of matrices in R. In our next session, we will look at how to modify and transform the matrices.
And welcome to this lab session. In this lab lesson, we will learn about how to modify and perform matrix operations. Let's begin. Here we have the matrix X declared. So we have elements from 11 to 19 and stored in a column-wise format. Let's create it. Then in line 7 and 8, I am giving the column names and row names as C1, C2 and C3, R1, R2 and R3. Let's name them and see the matrix. So here we have our matrix with our assigned names. I have replicated the result here.
Now you can see each element against their respective index numbers. Like 11 is at index 1, 17 is at index 7. The point I'm trying to make here is that you can also access the elements of the matrix directly using the index number. In this defined matrix X over here, we have defined it in the column order. So you will notice here that I have also written index numbers for the matrix. Let's now access the element 8 of the matrix. So I have written this in line number 14. Let's run it. And here we get the 18. Alright, so moving on next to the other matrix declaration, I will create the same element based Y matrix here. And this time we will create it in the row-wise order. So you can see that this time the matrix has been declared in the row-wise order, but the index numbering will always remain the same, just like the previous example. Let's now access element 8 this time from the matrix Y. So here we get 16 because 16 is present at index 8. You can also alter the values of the matrices after declaring them. Let me display the X vector first. Here it is the numbers from 11 to 19 in column-wise order. If you remember from the previous lecture, in line 32, I'm trying to access all the column elements of row 1. Let me run it. And here we get all the row 1 elements. Next, in line 33, what I'm trying to do is change the elements for this row from 11, 14, 17 to 20, 30 and 50. Let's run line 33, and in line 34, I will display the updated matrix. So here you can see that the elements of row 1 are updated. This is how we can change the elements of a matrix. In the same way, in line 35, I will change the elements of column 2 to 70, 80 and 90. Let's run it and see the updated matrix. So you can see that column 2 is now updated with our new values. This is how you can change the column elements. Alright, so if you want to transform your matrix, for example, over here in line number 40, I want my matrix to transform into a matrix where each element in the matrix X that is not divisible by 5 is replaced by 1. Maybe I want a matrix that is multiple of 5. So here the % operator checks for the remainder, as you know. If the remainder is 0, that number is divisible by 5, which means I'm not changing them. But those whose remainder is not equals to 0, that element will be replaced by a 1. Let's run it and see the updated matrix. So here you can see that all elements that were not divisible by 5 have been replaced by 1. So our matrix is now transformed. To transpose a matrix in R, we use the transpose function T. Our transpose function converts all the rows to columns and columns to rows. So here is the original matrix Y, and when I transpose it, you can see that it converts as per the transpose function. So this is it for this lab. I hope you have got an idea on how to perform the matrix transformation and modification in R. In our next lab session, we will look at how to perform matrix operations. Hello and welcome to this lab session. In this lesson, we will learn about arrays in R programming language. Array is a data structure that can hold multidimensional data. These are used to store multiple values in a single variable instead of declaring separate variables for each value. Let's look at declaring an array in R. Here is the syntax to declare an array in R. We use the array function for this purpose. The input arguments are the data which will be stored in the array, the dimensions of the array which contains the array rows, array columns, and the number of matrices. Then we have the dimension names for the array matrices. Let's declare our first array. First, I have declared here a vector vec_1 in line number 14. We have elements from 1 to 9. So a vector is a one-dimensional array in our programming. Then we have declared our first multi-dimensional array in line number 18. The data of our array is defined as number from 1 to 12. Then I have given the dimensions for n-dimensional array as 2 rows, 2 columns and 3 matrices, which means that our array is 3-dimensional and the data, which are numbers 1 to 12, will be splitted into 3 matrices of dimension having 2 rows and 2 columns. Let's run line number 18. So you can see that 3 different matrices with 2 rows and 2 columns are created. In the console here, the (1) value means that this is the first matrix of our 3-dimensional array. and below this you can see the first matrix, the second matrix, and the third matrix. So I have written the output matrix over here in line number 19 for you as a comment, so that is easier for you to take reference. Like matrices, you can also name the arrays as well. Here in line number 25, I am assigning the row names, then the column names, and then the matrices names for 3 matrices to their specific variables. And in line number 28, I am creating a new matrix with numbers from 1 to 12. The dimension is 2 for rows and 2 for columns and 3 matrices. This time I have also used the dim names argument and assigned the names to the rows, columns, and matrices. Let's run it. So this time you can see that we have the assigned matrices and their dimension names displayed in the output. With this, I hope you have got an understanding on how to create arrays in R. In our next lab session, we will look at how to access the elements of a matrix. Hello and welcome to this lab session. In this lesson, we will learn how to access the elements of arrays in R. As discussed in the last lab, here we have a one-dimensional array, also known as a vector. To access the elements of one-dimensional array, we simply give the index number of the elements, as we have seen in the vectors also. Here in line number 19, I will access the third element of the array. Let's run it. And here we get the output. Now here I will declare the 3-dimensional array, run lines 12 to 16. Now I am accessing the matrix of one of the vectors in line number 18. The number 1 here after the 2 commas shows that we are trying to access the respective matrix number in our array. Let's run it. So here we get the first matrix of our array. In the same way, I am accessing the second and third matrix of the array in line 19 and 20. Let's run it. You can also use the print function to print the elements of the array. Like here, I am printing the first matrix of the array in line 22. So first I will print the string that says this is the first matrix of the 3D array, and then the third matrix of the array gets printed. Let's run it, and here is the result. Alright, let's move on and see how to access a specific column of a matrix in an array. Here in the line 27, I will print the 3-dimensional array itself. Now first access the first column of the first matrix. Now run the code and you get the first row of the matrix 1 in the array. Next, I will access the first column of the first matrix. So here it is, we get the first column of the matrix. You can also access the elements of matrix using the dimension names. So let's run it. And here is the result. Now let's see how to access elements individually for ND array. I will print the array for you again. Let's run line number 41 and here is the array. Just focus on line number 43. I am accessing the second row and the second column element for the first matrix of the array. Let's run it. We get 4 as this is the element present at the specified location. For the next case in the line number 46, I am accessing the second matrix element which is present at row 1 and column 1. Let me run this. So we get 5 here as this is the element present at this location. You can also access the subset of an array matrix. So how to do this? Let me first declare an array of 2 rows and 4 column dimensions with 2 matrices. Let's run it. So you see we have the array my_array with 2 matrices having elements from 1 to 16. Here in the line 54, what I am doing is extracting the subset of matrix from matrix 2 of our array. In there, I have kept the row argument empty, which means I am accessing all the rows. While for the columns, I am selecting the second and the third row. So what I must get is the element 11, 12, 13 and 14 from my original array. Now let's run it and here we get the expected result. In the same way for the second case in line number 57, I am accessing the columns 2, 3 and 4 from matrix 2 with all the rows selected. Now let's run it. So we get 3 columns here. With this I hope you got an understanding on how to access the elements of the arrays in R. In our next lab session, we will look at how to perform basic array modification and transformation. Hello and welcome to this lab session. In this lesson, we will learn how to modify and transform your multidimensional arrays in R. Let's declare a 2-dimensional array with elements from 1 to 16. Now run line number 5. If you want to check the dimension of your array, We use the dim function. Let's run line 6 to see the dimension of our array. And it gives 2, 4, 2, which means that our array have 2 rows, 4 columns and 2 matrices, meaning that we have a two-dimensional array. Let's display our array. Here are our matrices in our array. So in line 10, now I am going to access the second and third column with all rows of the second matrix. Let me run it. Here I have my subset of the matrix 2 for the declared array. Next, we will modify these elements in the array. So I will replace the 4 elements with these values. The values here that are 1, 2, 3 and 4. Let's run it and see the modified matrix. So here you can see that our matrix 2 for the array is modified with the updated values. In the same way, here in line number 14, I am accessing the row 1 and row 2 with all the column matrix of matrix 1. This must return me the complete first matrix of our array. Let's run it. So here we get our first matrix of the array. This time I am going to update all the 8 elements with this new element vector, and then we will look at the updated matrix. Let's run it. So here our first matrix is completely modified with the new updated values. Okay, so like matrix transpose, you can also perform the transpose operation on the matrices in an array. Let's run line 18. And here is the transpose of the matrix. You can also transform the matrix by performing some operations. So here in line 21, we are looking for the numbers that are not divisible by 5. For all such values, the specific element gets replaced by 1. Let's run it and check our transformed matrix. So you see we get all the elements not divisible by 5 replaced with 1s. This is how we perform matrix transformation and value modifications in R. I hope you have got a clear understanding of it. In our next lab session, we will look at some basic array operations. Hello and welcome to this lab session. In this lesson, we will learn to perform some array operations in R. Let's declare the two arrays X and Y. Both are two-dimensional arrays. And here is the result for both. So now in line 11, the first operation we are going to apply is the addition of two matrices in array X. Let's run it. And here we get the result for two matrices in array X. Operations on arrays can also be performed using the apply function. So let me first display the array X for you. Now in line 20, I am applying the sum function on matrix X. This will perform the row-wise sum of the values for matrix 1 and 2. So it adds the raw element of matrix 1, that is 1, 3, 5, 7, and matrix 2, that is 9, 11, 13 and 15, and gives the first result. And then it adds the second raw elements of both matrices and give the result. Let's run line 20 and 21. So here we get the results 64 and 72. Here 64 is the sum of all the elements of row 1 for matrix 1 and 2, and 72 is the result for all elements of row 2 for both matrix 1 and matrix 2. You can also perform the column-wise addition of elements. This can be seen here in line 25. Let me again first print the matrix X for you. This time in line 25, I am going to calculate the sum of elements in column-wise fashion. Let me run it and discuss the result with you. Here is the result 22, 30, 38 and 46. The 22 is the sum of all elements in column 1 for both matrix 1 and matrix 2, and so are the other values as well, each representing the sum of their respective columns for both the matrices in array X. Using the apply function, we can add both the matrices of array X with one another. This is what we are doing in line 29. Here we are adding two matrices together. Now let's run it and see the result. So here is the sum of the two matrices in array X. Let's move on to calculate the square operation. So in line 34 here, I am calculating the square of array X. This will return us a matrix with a square of the values of each element. Let's run and see the result, including the original matrix X itself. So here is the result that contains the square of all the values. Alright, so next we have the square root operation. Let me print the original matrix X first. And in line 39, I am applying the square root operation on matrix X in a column-wise fashion. Let's run line 39 and 40. Here is the result for square root of the values. Let's change our function to the mean, which means the average. So here in line 44, I will calculate the mean of values in a column-wise pattern. Let's run it. We get the results 5.5, 7.5, 9.5 and 11.5. The value 5.5 here is the result of adding all the elements of column 1, that are 1, 2, 9 and 10, and then dividing it by 4, so you get 5.5, and so are the other values. You can also calculate the mean of all the matrices together. Here is the code in line 49. So this will perform element-wise average of both matrices and return the result. Let's run it. So we get the complete matrix result for mean. The last operation I will be discussing is the subtraction. Let's first print the two arrays, X and Y. Now in line 55, I will perform the subtraction of arrays X and Y. Let's run it. And here we get the resultant array with two matrices. So this is how we perform the array operations in R. In our next section, we will look at the list data structures. Hello and welcome to this lab session. In this lesson, we will learn about creating lists in R. Lists are the R objects which contain elements of different types like numbers, strings, vectors, and another list inside it. A list can also contain a matrix or a function as its elements. List is created using list function. Alright, so here I have declared 4 different vectors. First is the color names that contain strings for the color names. Next is the vector of numbers. Then we have a single logical value as true, and finally a vector containing double data type value. Let's run it. Next, I have created a variable name list_data1, which will contain the list of the above declared vectors. So to create a list, we use the list function, and inside I have the names of different data type vectors. Let's run it and then print the list. So here you can see that we have 4 different elements of different data types in the output. This was the one way of declaring the lists. Another way is that you directly enter the elements of the lists as in line number 21. Here the first element of the list are month names, April, May, June. The second element is a matrix with these listed numbers having dimensions of 2 rows, and then another list which we will call the sublist that contains 2 elements, a string and a numeric value. Let's execute it and print the list_data2. So here we have the list data2 printed. You see in the console 1 inside the double square bracket. This means that this is the first element of the list. Then inside the first element we have a vector with 3 strings value. Next we have 2 inside the double square brackets. This means that this is the second element of the list having a matrix of 2 rows and 3 column dimensions. And then we have a sublist. The 3 inside the double square bracket shows that this is the third element of the list data2, and in there we again have 3, 1 inside the double square brackets. This shows that within the list element 3 itself there are 2 different elements of another list number as 1 and 2. You can also name the lists after declaring it, like here in line number 26. So the names function takes in the vector of string names, the second quarter, the matrix A, and the inner list. Let's run it and then print the named list. So we have the same matrix again, but with names assigned to the list elements. Second quarter, matrix A, inner list, and inner list 2. Now I am declaring a list X over here with the first element named as A, having vector numbers. Then we have element named as B, having logical vector, and the last element C, having numbers 1 to 3. Let's print it. So here we have our list. Now to get the length of the list, we use the length function. Let's check the length of our first list, list data 1, and its length is 4 as it contains 4 elements. Then let's see the length for list data 2 and the list X. So it is 3 for both, as both contain 3 elements in theme. So this is how you create the lists in R. In our next lab session, we will learn how to access elements of lists. Hello and welcome to this lab session. In this lesson, we will learn how to access the elements of a list. Here I have declared a list with name list_data having elements as string with month names, then matrix A having some numbers, and an inner list which is a sublist having 2 elements. Let's run it. Let me print this list. So here is our list. To access any element of the list, we just provide its index number. Like in line number 14, I am accessing the index 1 element of the list. Let's run it. So here it returns the first list element with its name, the name of the month. Similarly, in line 17, I will access the element 3 of the list data, which is an inner list itself. Let's run it. So here we get the inner list as output. You can also access the element of a list by its element name directly. Here in line 20, we have given the name of the list element, that is matrix A. Now let's run it. So here it returns the matrix A, which is the second element of the list. Negative integer indexing can also be used to access the elements of the list. But in that case, same like other cases we have discussed in previous lessons, that with a negative integer index number, the R interpreter returns all other index elements except for the mentioned one. Like here I have written -2, so the element it will return are the elements at index 1 and index 3. Let's run it. So you see it returns the elements at index 1 and 3 of the list. We can also use logical indexing to access the list element. We know that we have 3 elements in our list. So in line number 29, we are accessing the index number 2 element because the index 1 and index 3 is stated as F, which means false. So it will return us the element at index 2 only. Let me run it. And here it returns the second element of the list. This is how you can access the elements of a list in R. In our next lab session, we will learn how to modify and transform the list values. Hello and welcome to this lab session. In this lesson, we will learn how to modify or transform the elements of lists in R. Let me declare the two lists here we have list data1 and list data2, same as previous examples. Let's run these lines. Merging a list is done itself using the list function. This will combine the two lists. So here I will combine the two lists, list data1 and list data2, and store it in a variable list data. Let's run line 11 and 12 and look at the new list. So here we have the list merged, but both as inner lists. Next, we will look at how to convert a list to a vector for a list having the same data type as numeric. So for this case, I have declared a list here as list_1, having elements 1 to 5. So let's check the class of this variable. So you can see the class of this list1 is list. Now to convert it into vector, we use the function unlist. So I have used the function unlist and passed the list1 as argument and storing it in a variable vect_1. Let's run and see the class for new variable. So now it is changed to integer. Alright, so now we will see how to add elements to a list. First, I will declare a new list with the name mylist having elements as string names, numbers, and logical values. Let's run line 26 and 27. Now we will add a new element in January to this list. So in line number 29, as we know, we have 3 elements in the list. Therefore, at index number 4, I will add this new element. Let's run it and let's print the updated list. So now you can see that we have the new element added in the list. We can also remove an element from the list. So here in line number 34, we are removing the first index element of the list. For this, we assign a null value to that element. Now let's execute it and check the updated list. So you see the first element, that was the names in the list, is removed from the list. We can also search for a particular element if it exists in the list. Here in line number 39, I have declared a list of color names. In line number 40, I will search for red in the color list. So for that, we use %in% operator for this purpose. Let's run it. So it returns true because the color red is present in the list. Next, let's search for the yellow color in the list. So here it returns false because this is not present in the list. You can also append values in a list. Here we have the color name list. To append a value, we use the append function. In the arguments, we provide the list name, then the value, which is blue in our case, and then the argument after, which states the index position after which you want to append the value. Now let's run it. So you see the color blue is added after pink in the list. This is how we perform modifications and transformations to the list in R. In our next lab session, we will look at how to perform some list operations. Hello and welcome to this lab session. In this lesson, we will look at how to create data frames in R. A data frame is a table or a two-dimensional array-like structure in which each column contains values of one variable and each row contains one set of values from each column. The data stored in a data frame can be of numeric, vector, or character type. Let's create a data frame for the student data where we have the student IDs, their names, and their marks. So to create a data frame, we use the function data.frame. Here we give the name to the data frame as student.data, and inside the data.frame function, we have 3 arguments. First is the student ID, that is from 1 to 5. Then we have the student names. So here are the 5 names: Williams, James, Olivia, Steve, and David. And last is their marks. student marks for each student. Let's create it and let's run this. So our data frame is created. To display the data frame, simply write its name and run it. So here you can see the tabulated data we just created, where we have the student IDs, their names and their marks, and the columns headings we just assigned in the data frame. To look at the structure of the data frame, we use the function str. Let's run it. This gives the complete information along with each column data type. To look at the summary of the data frame, just use the summary function. Here when I run it, this gives the complete summary of the data we have. And for the numeric values, it shows the statistics data, and for the strings, its length and class. Length of the function is used to look at the length of the data frames. This basically gives us the column count in most of the cases. So here it returns 3 as we have 3 columns as well. Then we have the dimension function, which gives the information about the number of rows and columns. So we have 5 rows and 3 columns. We can also check the rows and columns individually as well. Okay, then we have the attribute function. This shows the overall information of the data frame, its names, class and row names. Alright, so here in line 38, I will declare a new data frame which contains the user data. So we have serial numbers from 1 to 5. Then we have names, their ages and their heights. Let's print the data frame and run line 38. This time we will look at how to write the data frame to a CSV file. For this, we use the function write.csv. The input arguments are the data frame, then the name of the file that you want to save with, and then giving raw names as false because we don't want raw names to be in the CSV files. If you want them, just change it to true. Let's run it. Here you can see in the file list, the CSV is created. Let me open it for you. So here is our saved data. We can also import the data as a data frame. Here I have the famous Titanic data set. You can also find the file for it in the resource section as well. So to import a file, we use the function read.csv and give the file name. I have directly given the file name because it is in my current working directory. Now let's save it in the Titanic dataset variable first. Then I will convert it into the data frame. Let's print it. So here you can see the data frame for Titanic dataset is printed. This is how you create data frames in R, export them to a CSV file, and import a CSV file as a data frame. In our next lab session, we will look at how to access the data frames in R. See you in the next lab session. Hello and welcome to this lab session. In this lesson, we will look at how to access the data frames in R. So here we have the 2 data frames. One is for the student marks for the English course, and the other is for the student marks for the mathematics course. Let's create the 2 data frames. So for that, I will run the code. Okay, so the 2 data frames has been created. Now next, let's access the student.datamaths data frame. So here in line number 19, I will access the first column of the data frame. Let's run it. So you see, it returns the student IDs from the student.datamaths data frame. You can also use the negative integer indexing. So the phenomena is the same as here in line 22, I have written -2. This means that we will access all the columns of the data frames except for the column 2. Let's run it. So here you see we get the first and the third column of the data frame. Columns of the data frames can also be accessed using the $sign. So to access the respective columns, we write the data frame name. Like I have written here student.datamaths. And after the $sign, I am to access the column with name student underscore marks underscore maths. So this will access the marks column for this data frame. Let's run it. And here it returns the marks values in the form of the vector. Now we can also access the columns of the data frame and save itself in a data frame format. Like here in line number 28, we are storing the column names and marks from the student.dataEnglish data frame and storing it in variable marks underscore English. Let's store it and then let's print the result. So here we get the table in which we have the names and their marks for the English course. Now we will look at how to combine different data frames in a variable. So we have the student IDs and student names in both the data frames we declared, right? So what I'm to do is store the marks of the student for both the courses English and maths in a single variable. So here we are accessing the complete data frame student.dataEnglish and only the marks column which is at index 3 of the data maths data frame. Let's run it and print the result. So here you can see we get the combined data frames with student names and their marks for both the courses. The same can also be done using the $sign to access the same index column that contains the student marks in the student.data-maths data frame. Now let's execute line 35 and 36 and here you will find the same results. And here it is. So we get the same result as before. You can also export the file in a CSV format. So to do so, we use the write.csv function. Here I am saving the result data frame as marks.csv and I am not saving the raw names, just the column names. So let's run this and the file is created in the current working directory. Let's refresh it and here is the file. Let's open it. So this is the output. So this is how we access the data frames in R, and in our next lab session we will look at transforming and modifying the data frames in R. Hello and welcome to this lab session. In this lesson we will look at how to modify the values and update the values of the data frames in R. Here I will first declare the data frame with the name student.dataEnglish. It is the same as the previous ones. Let me create it and print the data frame. So the first transformation we will do to our data frame is adding a new column to the created data frame. I will add a new column which will represent the grades for the marks of the students. So for this we use the cbind function, short for column bind. This binds the newly defined column with the previous columns of the data frame. The column name is assigned as grades. Now let me run line 17. Now let's print the updated data frame. So here you can see that we have the updated data frame with the grades column now in it. You can also add a new data entry for the whole data frame. So over here in the line 24, I have defined a new student data. His name, ID, marks and grades. Now let me create this data. So let's run it. Now let me print the new student data for you. Here you can see we have his ID as 6, name as George, his marks and his grades as well. Now I will add this data to the previously created data frame. So to update this entry, we use the rbind function. That is short for raw bind function. Here we have entered the name for data frame, which is update1.std data English, which was the one we added grades in, this one. And then I give the second argument, which is the student data. Let's run it and let's print the new updated data frame. So here you can see we have the updated data frame with the sixth entry in here. Dropping a row in the data frame can be done this way. So here I have created a new variable with the name update3.stdDataEnglish. And from our update2.stdDataEnglish, we will fetch all the rows except for row 2. Let's run it and check the newly updated frame. So you see that row 2, which contained the data for James, is now deleted. In the same way, we can also drop a particular column, like here I will drop the fourth column from our data frame, which is the grades column. And then I will save it in the update4.stdDataEnglish. So here you can see that the grades column is now dropped. Now let's see how you can get the column of a data frame in the vector format. So over here, I'm accessing the first column of the data frame. Let's run it. So here we get student IDs from 1 to 6. And if we access the same index number using the double square brackets, R returns the values of that column in the form of vectors. So I hope you have got an understanding of how you can transform and modify data frames in R. In our next lab session, we will perform some basic operations on data frames in R. Hello and welcome to this lab session. In this lesson, we will learn about factors in R. A factor is a variable that is used to categorize and store the data, having a limited number of different values. It stores the data as a vector of integer values. Factor in R is also known as a categorical variable that stores both string and integer data values as levels. Let's have a look at it. So to create a factor, we use the factor function in R. Here I have declared a vector with strings having the priority levels of a word or an order. The priority have random values of low, medium, and high. So as you can see that there are randomly available priority. So to extract the number of categories of this status, we use the factor function. So in line number 20, we have the variable factor underscore work priority. Here we store the factors of vector work underscore priority. Now let's execute it and print the results. This shows you in the results that there are 3 levels in this vector that are high, low, and medium. This is helpful when you have multiple categorical data and you want to get the names of their categories or to look at how many categories it has. So to only get the levels contained in a vector, we use the level function, as in line number 23. Let's run it. So it gives only the levels in the vector. Now let's have a look at on how you can access the elements of the factors. So here in line number 27, I will print the factor variable itself. So you can see there are 20 elements in there. This can also be checked using the length function. So it gives the output 20. Now in line number 29, we access the first element of the factor variable. So it returns low. Then we give -2 in the index, which will return all the values except the second value of this factor variable. Factors values can also be modified. So here in line 35, I am changing the value of fact underscore work priority factor. The value at index 1 we previously saw was low. And now I am updating it to medium. Let's run it and print the result. So here the first value is changed to medium. Let me show factors to you with another example. So here I have a vector of numbers that are random. So in line number 42, I will create a factor vector for this. Let's run line 42 and 43. So here we get the value levels 1, 3, and 4, which means that in vector v underscore num, there are only 3 variables with multiple repetitions. Now to To only check the levels, we use the level function. When I run it, it returns the three categorical values, that is 1, 3, and 4. Let's have a look at categorical variable factors. So first we have the nominal categorical variable. These are the ones in which the order does not matter. Levels can have any order. So here I have a vector with color names. Let's create it. Now in line number 55, I will create the factors and print them. All the values are returned to us. As there are no multiple categories, each name is a separate level for this case. Next, let's have a look at the ordinal categorical variable. In such variables, the order of the levels for factors does matter. It can be the time of the day, like morning, evening, night, where the order of levels matter. So here in this example, we have different categories of a product in a production line. So we have a vector of the product class having random class, class B, class C, and class A. Let's create this vector. Just look at how I'm creating the factors for this one. Focus at line number 62. I have given the vector name the same as before. I have added argument order equals true, which means that the order of the categories for the values in the vector does matter to us. So in the third argument, we provide the order of the levels as well in the form of a vector. So our order for these levels are first is class A, the class B, and then the class C. Let me run line 66. And here you can see that this time it returns the levels with its order of priority also mentioned. We can also use the numeric codes instead of the class names or any other case as well. So for our current case, we have class A, B, and C. Let's say the number 0 represents the class A, 1 represents the class B, and 3 represents the class C. This assignment can be done using the factor function and using the labels argument in there. So this time in line number 73, I have also added a label argument where we give the values to the actual class string names. Now let's run it and print the result. So you can see that in the original vector, class A is replaced by 0, class B by 1, and class C by 2. With this, I hope you have got an idea of how to create factors and levels in R and how to access and transform them. In our next lab session, we will look at how you can split a vector based on the levels in a factor for a vector.
Hello and welcome to this lab session. In this lesson, we will learn how to split a vector according to the factor levels. So here I have declared a vector of different product classes. In line number 6. Run this line to create it. Then, as done previously, we are labeling the class names string with the numeric values. So the class A will be labeled as 0, class B by 1, and class C by 2. Let's label and see the printed result. Now in line number 15, we will split our v underscore class vector according to its factors. Let's run it and print the result. So here you can see that we get the output which has all different classes splitted. So we have one element for class A with label 0, 3 elements for class B labeled as 1, and then we have 2 elements for class C with label as 2. Let's look at another example. Here we have a vector of sold quantity. Maybe this vector represents the quantity of sold items in different regions or countries. So let's run it. Then we have the factors with 3 different levels, class A, class B, and class C.
So let's say for a particular region, there were 50 items sold, which were a class A type product. Then for some other country, we had 41 items sold, which were of class C, and so on. So to summarize the sold quantity type product, we can use here the split function. In line number 27, we are splitting the vector we underscore sold quantity with respect to their classes. Let's run it. So you see, it gives the individual sold quantities for each class product. Like class A have sold items values as 50, 41, 49 and so on. Class B has 68, 77 and 69. And then we have these values for class C. Once you get these values, you can then apply different functions to calculate for their statistical values, like the total number of class A products sold, their mean, standard deviation, and other such parameters. We will discuss such operations on factors in our next lab session. See you then. Hello and welcome to this lab session. In this lesson, we will learn how to apply functions on factors in R. Tapply and by function are used in most of the cases when talking about operations on factors. Tapply computes a measures like mean, median, min, and max, or a function for each factor variable in a vector. It is a very useful function that lets you create a subset of a vector and then apply some functions to each of the subset. Let's begin by creating a vector the same as previously we did. So the vector here represents the quantity sold for the different products. Then we have a factor declaration which shows the different classes of the products sold, that is the category of the product class. Now let's begin with the first operation. As in line 13, here we will calculate the mean of the sold quantities with respect to the product class. Let's run it. So you see that the average product for class A that were sold are 50.2 and class B were 71.33 and it was 56.66 for the class C. Similar to calculating the mean, we can also calculate the sum. So here in line 16, I have calculated the sum for the same case. And here is the printed result, which shows the total number of products sold for each product quantity class. We can also calculate the statistical parameters like the standard deviation. So here in line 19, I am calculating the standard deviation for the same case. Let's run it. And here are the results for the standard deviation of each class type. The tapply function returns the answer in an array format. So if I show you the class here, you can see that the class is an array with a type of double. Another function used in R to perform operations on factors is the by function. By function in R applies a function to specific subset of data frames. So here in line number 24, we are applying the by function to perform the sum operation. Let's perform it and print the output. This time we get the same output as the normal sum using the tapply function, but this is a more summarized result. So the class for this b underscore sum is by and the type is double. Now to access the result variable either performed by tapply or using the by function methods are the same. Here in line 29, we have the variable which has the sum result for the factors using the tapply function, that is t underscore sum, and in the next line I am to access the first element of the t underscore sum. Let's run it. So here it returns the first element, that is 251. For the other case, we print the result of the sum that was performed using the by function. Now run line number 32 and then access the first index of it. So here we also get the same answer, which is 251. The only difference is of the class of the returned answer. So if you want to convert the output of the by function to a list, we use the as.list function. So here you can see in line number 34, we convert the b under. So here you can see in the line number 35, so here you can see in line 35, we convert b underscore sum to list and then print it. And we get the list type answer. And the class is also of the type list now. So this is how we perform operations on factors in R. I hope you have got a clear understanding on R data structures by now. So in our next section, we will begin by performing some visual analysis of data in R using graphs and charts. Hello and welcome to Data Visualization with R programming language. Before we dive into visualization in RStudio, it is important to understand what is visualization. So starting off with the concept of visualization, data visualization is the practice of translating information into a visual context, such as a map or a graph, to make data easier for the human brain to understand and pull insights from. There are three primary goals of data visualization. The very first is to explore. Exploratory data analysis is an approach to analyzing datasets to summarize their main characteristics, often with visual methods. The second is analyze. Data analysis is defined as a process of cleaning, transforming, and modeling data to discover useful information for business decision making. And lastly, present. Presenting data involves the use of a variety of different graphical techniques to visually show the reader the relationship between different datasets, to emphasize the nature of a particular aspect of the data, or to geographically place data appropriately on a map. There are 5 stages of data visualization in general, through which the data is passed to extract meaningful information. And these stages includes purpose, that is the foundation of a project. Define the relationship amongst the data. Create visuals for representing the data. Use visual properties to define different levels of data. Lastly, validation of the data through visualization. If you are wondering what are the different types of graphs and charts, their uses and names, this lecture summarizes them with examples and pictures. Chart is an essential part of working with data as they condense large amount of data into an easy to understand format. It is a graphical representation of data. Charts allows user to see what are the results of the data and to better understand and predict current and future data. Bar charts represent categorical data with rectangular bars. Bar graphs are among the most popular types of graphs and charts in economics, statistics, marketing, and visualization in digital customer experience. They are commonly used to compare several categories of data. For example, the bar chart here represents the total sum of the sales for product A and product B over 3 years. A line chart graphically displays data that changes continuously over time. So when you want to show trends, for example, how house prices have increased over time, and when you want to make prediction based on a data history over time. For example, the following line graph shows annual sales of a particular business company for the period of 6 consecutive years. The pie chart breaks down a group into a smaller pieces. It shows part-whole relationship to illustrate numerical proportion. To make a pie chart, you need a list of categorical variables and numerical variables. It is very useful for displaying nominal or ordinal categories of data, and to show percentage or proportional data, or when comparing areas of growth within a business such as profit. For example, the pie chart here represents the proportion of types of transportation used by 1,000 students to go to their schools. The histogram displays a frequency distribution of a dataset. At first glance, histograms look alike to bar graphs. However, there is a key difference between them. Bar charts represent categorical data, and histogram represents continuous data. The uses of histograms are when you want to represent the shape of the data's distribution and when you want to see whether the outputs of two or more processes are different. For example, the histogram here represents per capita income for 5 age groups. Scatter plots helps you predict the behavior of one variable, that is dependent variable, based on the measures of the other variable, that is independent variable. And the uses of scatter plots includes that when trying to find out whether there is a relationship between two variables, or to predict the behavior of dependent variables based on the measures of the independent variables. For example, the following scatter plot presents data for 7 online stores, their monthly e-commerce sales and online advertising costs for the last year. Venn diagram uses overlapping circles to visualize the logical relationship between two or more groups of items. The following science example of Venn diagram compares the features of birds and bats. Area charts shows the change in one or several quantities over time. The area chart below shows quarterly sales for product categories A and B for the last year. It is a form of the line chart that represents smooth curve through the different data points. We use a spline chart when we want to plot data that requires the usage of curve fitting, such as product life cycle chart or an impulse response chart. The following spline chart example shows sales of a company through several months of a year. Bubble charts are super useful types of graphs for making a comparison of the relationships between data in 3 numeric data dimensions: the y-axis data, the x-axis data, and the data depicting the bubble size. We use bubble chart when we have to display 3 or 4 dimensions of the data and when we want to compare and display the relationships. For example, the bubble chart here shows the relationship between cost, that is on x-axis, profit, that is on y-axis, and probability of success, the bubble size. Dot plot is used for relatively small sets of data and the values fall into a number of discrete categories. We use dot plot to plot frequency counts when we have a small number of categories. Dot plots are very useful when the variable is quantitative or categorical. For example, suppose you have a class of 26 students and they are asked to tell their favorite color. So the dot plot below represents their choices. Hello and welcome to this lab session. In this lesson we will learn about bar charts in R. A bar chart or bar graph is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values that they represent. So here in line number 12, I have declared a vector with the name salary, and I have the salary over here and the values which are 200, 400, 500 and 800. Then in the next line, I have a variable with name DESJ, that is designation, This vector will basically contain some of the designations for which we have the salaries defined. So let me declare the two vectors. In the line number 16, you will see that we have used the bar plot function to actually plot the salary vector over here. Let's run this line and see the output for this bar plot. Here it is. In the lower right corner, you can see that we have got the graph for the bar plot for the salaries. So you can see here that we don't have the labels over here in the bar plot. So let's use some labels in here. So for that, I will give the names equals to designation over here in the bar plot function. Let's run it. Alright, so once you run this line, you will see that the bar plot now generates with the labels for the designation we have assigned. So moving on forward, let's see some more arguments in the bar plot function. So this time in the line number 19, I have a bar plot, then the first argument as salary, second argument as names, which will be designation labels. Then the third argument is the color. So this time we will give color to our bar plot, which is red. And then we have the main argument, which is the main heading of your bar plot. Then you have xlab, which is the x label. We have assigned its value as designation. Then the ylab, which is y label, which is the average salary in our case. Then the cex.main, and this is the font size of your main heading of the bar plot. Finally, the ylim, which is the limit of the y-axis that will be displayed on the chart. Let's run this code. So you can see that we have got the bar plot with red colors with a y-axis label, an x-axis label, and the main heading as well. Again, we have the same bar plot function here, but this time we have given two colors input as vectors. We have red and green color this time. Rest everything is the same, so let's run it. This time the graph is generated the same as before, but the color scheme this time is different, and we have alternate colors this time. Next, let's see some more arguments of the bar plot function. So in here on line number 28, we will print the same vector, but this time different colors for each bar. Next, we will use a space argument as well, and this is the distance between two bars in the bar plot. Then we have everything same as previously used. Let's run it. So you see that the colors are changed, and so is the distance between the bars itself. Now let's have a look at another example. This time we have earnings of a person on a daily basis. So we have the earnings vector and the days vector declared here. To plot this, we give the input earnings vector and the names as days. The y limit this time will be calculated automatically. So making the use of previous knowledge, we are using the max function here. This will calculate the max value in the earning vector and set the y limit maximum to the maximum value of the vector plus 50. Let's run it. So we get the graph here for the daily earnings, and it shows that the maximum earning was done on Wednesday. So this is how we plot the bar plots in R. In our next lab session, we will look at the line graphs in R. Hello and welcome to this lab session. In this lesson, we will look at how to create line graphs in R. A line chart or line plot or line graph or curve chart is a type of chart which displays information as a series of data points called markers connected by straight line segments. Here we have declared a vector x from 1 to 10. Then we have the variable y, which stores the square of values in x, that is square root of values from 1 to 10. In the line 14, we are using the plot function to generate the line graph for the calculated values of y. The type argument equals L here shows that the type of the plot is line graph. Let's run it. So here we get a simple line graph for the square values of x. Next, we will plot the same graph but with some proper formatting, adding in some labels. So we have our heading as x square graph, assigning red color to the graph, giving the x label as x and y label as x square, and finally the y limit as the values from 0 to 300. Let's run it. So this time we get the plot in red color with the assigned labels. You can also add another line graph to the same plot. Like right now we have the plot for x square, and let's say you want the x cube plot also to appear on the same graph. So for that I will first compute the x cube and store the result in variable y1. And to add a new line to the same graph, we use the lines function. Then we give in the arguments as x, y1, type as line graph, and color as blue. Let's run it. So you can see that now we have the two lines on the same graph. Alright, as the last example, I will make the line graph for the same example we did previously for the bar chart. So I'm plotting here the earnings and the days as a line graph. So let's run it. So here it gives a line chart, but you can see that we were getting better information on this data using the bar plot rather than the line chart. As you can see here, this was the previously created bar chart. So it also depends on the data that which chart will suit it to represent it in the visual format, just as in this case. So I hope you have got an understanding on how to create line charts in R. In our next lab session, we will look at how to create pie charts in R. Hello and welcome to this lab session. In this lesson, we will look at how to generate pie charts in R. A pie chart is a circular statistical graphic which is divided into slices to illustrate numerical proportion. In a pie chart, the arc length of each slice is proportional to the quantity it represents. Here we have a vector which contains the sales percentage of a product that is sold. Then we have the regions in which the product was sold. So the data says that 20% of the sales were made in the Middle East, then 45% in Africa, 47% in Europe, and so on. Let's visualize this data with the help of a pie chart. So here in line number 13, I will create a pie chart. To generate a pie chart, the pie function is used. Here we have the values vector, and labels are the region names. Let's run it. Here is a simple pie chart with just different colors showing different region sales. Let's make it a bit more elaborative. I want to show the percentage of each region on the chart. So for that, I will first calculate the percentage value of each region's sales value. This is done here in line number 15. The round function here rounds up the answer for the sales underscore PC vector, that is divided by sum of the sales underscore PC and multiplied it by 100. And then it rounds it to one decimal place. Now run it. Alright, so here are the percentage values. So let's create the pie chart. And this time we give it a main heading as the region sales chart and the color as rainbow colors. Now run the code on line 18. So here we get the pie chart with displayed percentages. Now one thing is missing here, the color code with respect to regions. So for that, we use the legend function as in line 21. So the legend will be displayed at the right top corner. The legends will be the region names and the font size of 0.8, and the color fill will be the same as rainbow color. Let's run it. And here we get the legend for this pie chart, which makes it completely understandable. So this is how we make pie charts in R. In our next lab session, we will look at histograms in R. Hello and welcome to this lab session. In this lesson, we will look at how to generate histograms in R. A histogram is a bar graph-like representation of data that buckets a range of outcomes into columns along the x-axis. The y-axis represents the number count or percentage of occurrences in the data for each column and can be used to visualize data distributions. So I have used here the sample function. This actually generates the random samples of numbers from 1 to 500 and a total of 200 samples. Let's generate and print it. Here are the 200 samples displayed. To create a histogram, we use the hist function. So here let me run this. And this is the histogram for x, which shows the frequency for different values existing in the samples we created. So for our next example, I have created here a vector y with 200 random normal samples. Let's create and print it. So here we have the random normal distribution having negative and positive values. Let's create a histogram for this one. So here you can see the histogram with random normal distribution. We can also add some labels and headings to the histograms. So for our data in vector x, I will use the label as histogram of 200 samples from 1 to 500. Let's run it. And here is the same histogram with the assigned labels. Color can also be changed using the call argument. Let's run it. And here we get the light blue color. So this is how we create a histogram in R. In our next lab session, we will look at how to create scatter plots in R. Hello and welcome to this lab session. In this lesson, we will look at how to create scatter plots in R. Scatter plots primarily uses R to observe and show relationships between two numeric variables. The dots in a scatter plot not only report the values of individual data points, but also patterns when the data are taken as a whole. Identification of correlational relationships are common with scatter plots. So here is the air quality data frame. There are some by default data sets stored in R. So we are printing the air quality data frame. If I scroll up to the top of the data set, you can see that there are 6 columns. Alright, so I will access the temperature column and the solar radiation column and store their values in the temperature variable and S radiation variable. Let's run line 13 and 14. To generate a scatter plot, we use the plot function. So here in line number 16, I am plotting the scatter plot for the solar radiation and the temperature. Let's run it. Here is the scatter plot for the two parameters. To zoom into the scatter plot in line 18, I have added the labels and limited the x and y axis ranges as you can see here. The x range is limited from 100 to 120 and the y range is limited from 40 to 100. So this will now only show the points in these ranges. Let's run it. So here you see the scatter plot now contains a few points available in these ranges. Let's have a look at another example. This time we will look at the deviation of the available values from the actual values. For this example, we have the square of the values from 1 to 10. And then we have a data set vector with some pre-calculated values. So we are interested in looking at the deviation between the act underscore values and the square values. For this, we will first plot the actual values versus x with the red color. So run line 31. Here is the scatter plot. Now to check its deviation from the square values, I will use the line function and plot the x squared values. And here you go. We have both the plots where the blue line is the square values and the red dots are the actual values. And here the values lying on the blue lines are the good values for us, whereas Others that are out of the path are incorrect ones. So this is how we use the scatter plot in R. In our next lab session, we will look at how to plot custom functions in R. Hello and welcome to this lab session. In this lesson, we will look at how to plot custom functions in R. I have created a custom function here. This takes the input value x, and inside the function it takes a square of x and adds x to it and then plus 1. Let's say I'm interested in plotting the values for this function. So let's first execute the function. So our function is declared now. To plot the function, we simply write the plot and pass the function to it, which is f in our case. Let's run it. R by default plug in the values for x and plots the values. And it has done by default for values of x from 0 to 1.0. Now I'm interested in calculating the function and plotting it for values of x from -10 to 10. So I have given these limits here in line number 15. So x limit is from -10 to 10. And here color will be blue and plot line width will be of size 3. Let's run it. Now in the same way, I have another function here that is f2. Let's also plot this one for values from -10 to 10. Run the lines from 19 to 24. And here is the plot for this function. So this is how you can plot the custom functions in R. And in our next lab session, we will look at how to save the graphs and export them. Hello and welcome to this lab session. In this session, you will learn how to export a graph or chart from R to use them for your reports or anywhere. Let me quickly run lines 6 to 10 from our previous examples to generate the pie chart. Now I will run line 15 to 18 to generate the pie chart. So to save this chart, you can see an export button on the top of the chart. In the bottom right window, just click on it and it then asks you for the output format. Select your desired output format. It can be image or PDF, and I will select the image format here. So click on, if you see at the drop down for image format, so these are the multiple formats in which you can save your image. I will select and proceed with the PNG format. And my location is the same working directory. Assign a file name of your choice. I will name it as my pie chart. Then click on the update preview to preview the updated chart and how it will look after the export. And here it is how it will look like. Next, click on the save button. And now your image is saved in the present working directory here. So this is how you save or export charts in R. With this, I hope you have got a basic understanding on the R course, starting from the basics, following through control flows, data structures, and then the graphical analysis. So happy coding!